This little spot will just turn from the south to north and going east to west. Okay, I'll stand by. I think it's good point until you're ready to go to the next one. That should be 80 seconds, just so you know.
Well, hello and welcome to Divestream 603. This is the first dive of this new expedition, conducting ultra fine-scale seafloor mapping. Currently, we are up in the midwater, and we are going to be staying in the midwater for a little bit. I'll actually toss up our altitude there. You can see that we are about 42 meters off the bottom right now. But we are pretty deep. We are 2,415 meters below the surface. So why are we hovering up here? Well, it has to do with our mapping that we're doing. And so for the first half of today's dive, we are going to be doing some mapping. And we're doing that with a number of tools, but I can put up one of them.
Start line 020.
And that is the M3 multibeam sonar there. So I'll leave that up while we're doing this mapping chunk. After our mapping, we're going to drop on down onto a hydrothermal vent site known as Rose Garden and do some exploration and opportunistic sampling. So across the front row, we do have Chris in pilot, Claude in co-pilot. My name's Alex. Some of you are all like, "Hi, Alex." Yep, I'm on for this cruise as the multimedia technician, so you will hear my voice a lot. But over in the science seat right now, we've got John Jameson, chief scientist for this cruise. So you'll be hearing folks kind of talking about this mapping, about this survey, and we'll see what we find. Current plan, I believe, is this dive's going to go on for quite a while yet, until early morning tomorrow. But as I said, first half is going to be this mapping, this survey. We actually have more equipment than just this M3. So we are also using Interferometric Synthetic Aperture Sonar, or InSAS, or you'll also just hear it called SAS. We also have a magnetometer on board. And so these all are allowing us to conduct different surveys as we kind of cruise here in the midwater. I'll post up the cruise page for this particular cruise if you want to learn a little bit more about our goals and the areas that we'll be visiting. As folks continue to trickle on in, welcome. This is Dive 603. So right now we're kind of mowing the lawn for folks that have been along on previous mapping dives. A little familiar, perhaps. with this one up instead. So there you can see our map has just kind of some back and forth lines on it. And we're just going to be working our way along that path.
Thanks, tell me about it now.
It's probably the first time we're gonna have a different concept.
So on the right side there, you can see at the bottom sort of the profile of the multibeam as it goes out. You can see the ground there. But then above we have that false color representation of the terrain. And we did get a peek of it right when we touched down at the bottom. We kind of touched down and then came back up into the midwater. It is pretty interesting terrain down there, so when we get back down there, we'll have to see what we find. After this mapping, we are looking to drop down. And so opportunistic sampling, things we're kind of looking for is if we happen to find a low temperature plume of hydrothermal venting, we can collect some water samples, any precipitates we might find out of hydrothermal fluid, lots of volcanic rocks down there. We saw some of the shimmering as well of that volcanic glass. Something we are keeping an eye out for, also skate eggs. So if you were on for, say, the Octopus Odyssey cruise earlier in the year, we found some skate eggs up on top of a seamount. We thought maybe this would be a skate nursery. So same sort of thing here. We're looking around for skate eggs or even the skates. Taking samples of some of the vent animals present. Of course, the riftia worms, clams, mussels. Also hoping to collect some sediment samples where we can. We do have push cores. There's also a pretty cool box core that I believe that's on board today.
It is.
Yep. So you can show that there. You can see in the porch there. On the right side of the porch, there's a little metal box there. There's an orange handle. Corals, also not out of the question. If you were around for our last expedition, right, looking at those vertical reefs, lots of corals there. We're going to keep our eye out for some corals around here as well. And if we have space, maybe some sponges.
End of line 020. 021.
You can see SuBastian over on the left side there of the map, turning to continue upwards along this path.
Why is it not going straight? It's going now is I think that just turn the work on that current while also that direction. But luckily the position of the vessel going more toward this easy tension. Okay, begin line 022. Starting line 022.
021, I think.
Oh, so from 021 or 202?
Oh, yeah, we're doing it from the start.
Oh, from the start line.
Yeah, sorry.
021, 022.
Yeah, we debated back and forth on that one and just chose.
So just like mowing the lawn, maybe your own lawn, right? You want a little bit of overlap. So you'll see as we're going back and forth on here, there's overlap between the previous line and the next line. If you didn't have overlap while you were mowing the lawn, right, you get those annoying little tufts of grass right in the middle that get missed. And for mapping, that would leave unmapped spaces, right? So less than desirable. So we do have a nice little overlap there just to play it safe. I made someone curious what the swath width is on the InSAS. Do you know what we're doing for that right now?
It's going to be 150 meters.
About 150 meters, it sounds like. Each side. All right. So each side out 150 meters because the InSAS actually is mounted on each side of SuBastian. And so it's sending out 150 meters on either side.
No, but we should be able to calculate that. Talk to Chris and see if they can give me a number. So I'm just wondering the total length for the surveys based on the we're doing now.
Like time-wise, yeah.
We could do the math.
Yeah. So we're going 0.5 meters per second, and then an additional fraction of a second for the rotation of how it actually moves.
Yeah, not that idea.
So these.
What are our line lengths?
Yeah. 300 meters.
Yeah. The offsets are 50.
I believe so, yes. Yes, 50. So 350 for each. 1, 5.
1, 0 left. Do that.
This as well.
Yeah.
Alright, 6
And
and
then-
6, and then the 6 is the plus and long.
Yeah.
So it'll be 7 seconds of 300 then. If we were to just, I mean, I know there's only 6 seconds, but it'd be 7, 300, so 300. Or sorry.
We'll have to come down the other side too. So.
Okay,
So.
Hey, can you go up there now?
Thank you.
About 19 and a half lines.
So, of course, our previous 2 expeditions were down near the Galapagos. The first one was looking at hydrothermal vents, including some of the same vents that we'll be visiting for this expedition. And then the most recent last expedition was exploring shallower regions and looking at those cold water corals. But we are returning to the deeper waters of the Galapagos spreading center, I suppose.
Like movie right here.
So Juliana and I actually have some overlap this time, so you'll hear her not while I'm just nodding off. But we've rearranged mission control just a smidge, so she is now currently stationed right over my shoulder.
Hey, buddy. Is this mic on?
That one? Oh, I can turn that one on.
No, you don't have to.
No, you can swing that over. We can get like a morning radio show going. Yeah, little shock jock.
Chris, how you doing?
So fun. One second. Where's your RV?
Hello, ROV, go ahead.
Okay, how are you? Is this the same heading that we were on to begin with, or did we change? I didn't notice.
I've just got around about 5 degrees in the last 2 minutes.
Okay, that gives me fun. Alright, thank you.
Do you guys need to go on a specific heading, or do you want a heads up or anything coming up? It's usually going to give you a call at like 10, 15, but just let me know if you need it for like smaller heading changes.
No, the heading is fine as long as it keeps us safe as regards to the position of the vessel. And yeah, if it's anything more than, say, if it's 10 degrees or more, then give us a heads up. Other than that, you're fine. I just was curious about the track line.
Awesome, no worries.
4 hours. You hear that?
4 hours.
I think we should sit.
Possibly this one as well.
Possibly.
Yeah, Juliana will be doing the 12 to 12. We got Jimbo on other 12 to 12, midnight to noon.
Yeah.
I don't know what Vite's time is, but you'll have Vite on here as well as Tomer. I'm not sure what are their...
We're doing 11 to 11.
They're doing 11-11s? Okay, a little bit of overlap. Yeah, and then I'm on 8 to 8s, just entirely off of everyone else's schedule. So yeah, the first half of this dive and of a lot of the dives here will be kind of just this chilling, this space truck in here as we cruise on through midwater with our sensors on and map what we can't see below us. Something that's kind of fun to me is that after we do that, after we have that survey, after we have this little map of this whole thing that we've been unable to see the entire time, we can drop on down to that, and we'll see maybe if we recognize any features or anything like that. But of course, we'll also be doing opportunistic sampling along the way. We do have, as I mentioned, we have the M3 multibeam, which is what you can see on your screen. But then we also have the InSAS, a synthetic aperture sonar, and a magnetometer. And we also have SuBastian's sonar, including the regular sonar we put up, which is kind of like a sweeping sonar, but we also have the Blue View back up and running for this cruise. So that one's pretty cool. It doesn't show anything right now because we're up in the midwater, but once we're down low, it can give us an image of what's in front of us, but in much more of a real-time aspect compared to the sweeping sonar that we use.
Yeah, it's basically
Yeah, like it is just sending out multiple beams at the same time. But yeah, like a live multi-beam.
forward-facing multibeam.
Yeah, forward-facing as well. But it's been like I've seen. I think my favorite thing with it is when we were just doing some testing. when we brought the ship across from Vigo in Spain over to Puerto Rico, testing out systems, and like the blue view, we could see a shark.
Yeah.
We couldn't see the shark in our cameras. It never showed up in our cameras, but we could see it just hanging out on the blue view, and you could actually see it like swimming around. So I'm excited to see, what that makes of the varied and interesting terrain of the hydrothermal vents. Yeah, you're going to be seeing all those weird stacks and layers and caves and bubbles and skylights, vents.
It would have been amazing on the vertical reef screws.
Yeah. Although the models they got with like the little crab that they modeled, there were some fish, I want to say, as well. Yeah. And I was joking with J-Rod and Chris. I was saying we should just mount like 4 of the blue views, pointing in all cardinal direction. Yeah, and just get like the full thing. You could have like the little God view that like pickup trucks have nowadays, where they give you like a simulated this is what's around you based off all the cameras.
Yeah, like Teslas as well.
Yeah. Although the blue view is currently set to the same amber as this M3 that you've got up there, and that's kind of...
Does that bother me?
It's kind of bothering me.
I'll talk to my people.
Yeah, Juliana will fix that. No, it doesn't matter. It's called blue view, though, you know?
I know, it should be blue.
Yeah.
Agreed.
Yeah. Yeah, we've got Claude in the co-pilot seat. A couple folks shouting you out in the chat. It seems like maybe folks that know you. So.
23.
So if we're picking up samples later, I don't know when we're going to get down to the bottom. We got to do this mapping first. It's got to happen. It's not all peek bagging and collecting. We got to get some science in here, and then we get to go look and do nice little careful sampling, so that scientists can get exactly what they want. We can bring it back up, and we can learn a lot about this. So we got a lot to do. Got the mapping, got the sampling, and then of course just the exploration.
Talk about how the ROV is trashing itself.
I suppose, yeah. Folks ask a lot of times, actually, if the ROV has like an autopilot, and it does, to a degree. So what can you use right now?
So right now we're using our internal navigation that built in on the vessel, out of the ROV, and we set waypoints throughout a grid that the ROV recognizes. And we list them numerically, so it knows, list 1 to 100 or whatever. We'll start at 1, and set it to go to the next waypoint, so it'll automatically go to 2. We can set it at the depth that we want it, the altitude we want it, the heading, the speed, things along that nature. And then it'll go at that speed, at that heading, at that altitude until it gets to the next waypoint. So once it does that, it'll stop. And we can do it a couple different ways. We can set it up to be concerned about the heading as it goes there, which we are right now, because we want to make sure that we're looking in the same direction for the mapping every time. Or you know which way we're heading. So it'll turn, say 90 degrees or whatever the heading changes to the next waypoint. It'll turn, face that, and go. If we don't have that, then it might go parallel, slider over there or whatever. But in this situation, we're turning and going to the actual point.
Yeah.
Less specific ones where I can just set a heading, I can lock that in, and we'll go. It'll hold that heading and just go. It's called cruise position.
So we've got some really simple ones where you just set that heading and just say go, and it kind of just says okay, and it doesn't take into consideration anything else. But then you can dial in what depth you want or what altitude you want. Okay.
So this one is going to a specific place, so it'll try to hold that heading and go for AG.
Right.
Do it the other way. It just says, all right, I'm going to go this way. And it's not quite as concerned about maintaining its relative position on the ground. Like, it's not saying, okay, I'm going to go in a straight line.
So we're having it follow these points right now, and we're pretty high up off the bottom. We're at almost 45 meters off bottom, but it's pretty varied terrain down there, and so there are little spires and chimneys and all that. With the ROVs doesn't really have obstacle avoidance though, so you would have to take control then if you saw something coming up.
If something comes up in the sonar that it's going to be in our way, there's a couple ways I could either try to fly up if it's something relatively passable. If it's too big and I wouldn't be able to come up in time, then I would just operate the controller that would take us out of our auto positioning, which is what we're using to maintain this specific line. I'd fly around it and now get back on the line and I would start it again.
Yeah. So touching the controls takes you right out of it, just like kind of tapping the brake on cruise control or something.
Yeah, touching this one, the one that does our axial and our lateral thrust, so our forward, back, spin, and left to right, that would take us completely out. Yeah. It's not as sensitive when I go to my verticals, so I can fly up and fly down and stay in the auto position unless I go super hard pull up or whatever. So it's not what I'm doing, what I usually would. If I put this altitude, hopefully that won't be an issue.
No, we're pretty high up. Although if we found something, if something came up 45 meters.
It's 145 meters? Oh, yeah.
We'd have to check it out probably.
When we were using the M3 previously,
yeah,
there were times we were doing it at a lower altitude, so we did have to avoid some higher spires. Higher spires, yeah. In our path. And I think that the scientists who set up those paths enjoyed that, so she would make sure we had obstacles.
All right, so we're still pretty early in the stream, and ultimately early in the dive. I don't know if it's changed. Original dive plan had us back on deck about 0800, so we've got a ways to go for that. But for folks just joining us, this is actually our first dive stream of this expedition, conducting ultrafine scale mapping of the seafloor. And there is a hashtag for this, that is mapping Galapagos vents. So I know there's already been some posts up on Twitter. You can check that out and follow along. What was that? X. Oh, yes, sure. I'm going to call it Twitter. If you go to twitter.com, it'll still take you there. Juliana was whispering at me, X. I was like, what is going on here? So yes, it's true enough. But yeah, you can follow along there, as well as I have pinned the cruise page for this cruise. So blogs will be posted up, updates will be posted up on that cruise page. Of course, over on our YouTube and Facebook, there'll also be videos posted giving updates of the expedition along the way as well. Dive 603. Some of you might notice, there's 602 missing in there. We just did a quick little shakedown for mounting the InSAS system onto the ROV. They have actually added a little additional flotation to ROV SuBastian, and so we just want to kind of dip it in the water, make sure that it sits nicely with that additional flotation on it, and it does. So here we are. Oh, we noticed that you noticed missing dives.
What did you do to me? I don't know. Bring a beanbag chair to the control room.
We could get you a beanbag chair.
I have honey.
Yeah. Go on.
Should I bring her in?
Yeah.
I can make that happen.
This is not our last expedition of the year either. So some of you may have noticed if you follow the cruise page or check out the cruise page over at schmidtocean.org, we finally have the cruise page posted up for leg 2 of Octopus Odyssey, or as it's listed on there, Octopus Odyssey 2, TOO, just like we are on Falcor 2. And so for folks that joined us for the first leg of Octopus Odyssey, exploring these octopus nurseries, these deep water octopus nurseries on top of hydrothermally active areas, we will be returning, or the ship will be returning. I will be home. Sophia will be on board for that one, but it should be interesting. Returning, collecting back some of the experiments, exploring some more of the region, and again, learning about these octopus and why they're where they are, and how they're doing. Last time was exciting because when we originally went, when we were headed out there, scientists were actually worried that those eggs weren't viable because an earlier expedition there hadn't really seen any active, for lack of a better term, eggs. Any developing eggs, and so they thought, oh, maybe the conditions just aren't right here. But while we were there, we did see some little octopus hatchlings, so very exciting. And I'll be tuning in myself.
End of line. Going to 5.
Caroline, is there any reason why listening would affect the M3s? No? Because otherwise we could do it during one of these.
We're doing it now.
Are you doing it now?
Yeah.
Okay, perfect.
So we turn off the SAS.
Just gonna listen. Not transfer.
So we have seen some critters as we're cruising through. We aren't really stopping because, of course, we're mowing the lawn here. But so far we've seen some sea cucumbers up in the water, including the Pelagiotheria that we had a lot of last expedition, that nice pelagic sea cucumber. Seen a couple squid as well, just kind of skirting on by. Siphonophores and some larvaceans, as well as jellies. So there's stuff up here. And again, we're not too far off the bottom, but I mean, if I put up the camera looking downward, we actually can't see the bottom, right? I mean, even though we're 40 meters away, just can't see it down there. But the sonar gets it just fine.
still listening?
Mhm.
And that's a distance.
Good work there.
Then there's all of these that have to get the regions. So that distance is probably about less than 2 kilometers. We know 2,000 even Darwin is not very much, but we're not there. Is his mic muted or on?
It's on. Yeah. We pick you up every once in a while if you're like there, but
Do you have 2 farms for your setup? Back in 2015, it's still active, but not as big as. So chances are
this one here.
just finding
So Chris just looked over. I am on the cruise page over at schmidtocean.org. And so we've got kind of an example of that ultra-fine scale seafloor mapping, what sort of thing we might get out of the InSAS. It's the header image, and it is that amber color. What is that?
I think it's rock.
Yeah, rock there. Lots of different types of mapping. In fact, there's an image. If you head on over to that cruise page, there's an image further down that kind of shows like the difference in scale, the difference in resolution that you get, right? Because more traditional mapping, or the maps that we have of a lot of areas of the ocean, it's not a great resolution. Like, we know there's something there, and if it's really big, we can see it. But the finer resolution we get, right, the more details we're getting. And so InSAS can actually get down to 2 centimeter resolution. So it's pretty fun. So yeah, check out that cruise page over at schmidtocean.org. And if you're watching live on either Facebook or YouTube, you can always type questions in the chat there. We try to get those answered as we can. Folks also usually let us know where they are tuning in from. We've got some folks tuned in from all over right now, it looks like. So that is fun. I hear some snacks. What snacks do we have in Mission Control today? The fruity gummies. Those are pretty go-to for the snacks. We've had gummy bears before. This came up last time. This came up last cruise.
They're not for me.
No, they're not for anybody. Just they're being metered out so that we don't get a little over enthusiastic, and they're gone by tomorrow.
That's smart.
Yeah, I haven't even seen them yet. I just heard that.
You were eating them.
No, those were. I stole those from Russ.
Russ wasn't even here. But there are gummy bears? Is that what you're saying?
There's gummy bears around.
Yes, so I've been told that there are a bunch, but
By whom?
Juliana's getting like gummy bear sweats going. There's gummy bears. Oh, we got a squidworm, looks like, maybe there.
It is smart to ration.
yeah, I tried that before, and it lasted about a third of the way through.
Yeah.
I was like, let's put these out, and then I come back and review them.
So the problem is when you put them out in rations, small bits. Everyone's like, oh, I gotta get them while they're here. So then everyone takes a lot.
Well, the problem with that also would be if I just put them all out, they'd be like, well, I gotta get them while I'm here, and it would just go away real quick.
How do we solve this?
Just more. We have to have more. Have to have more. Put it in the budget. Gummy bears.
Luckily, I have a spare internal to test my theory as well.
I think those might be
So
different.
I can do that while we're in the water.
There we go.
So this might not be my lead engineer.
Or try to bring some hard mango.
The dried mango.
What should I bring when I come back?
Just yourself.
Thank you, Chris. Oh.
I'm also bringing some
Yeah.
So, I'll just say those, the one thing
Now,
that's-
level is with elements. Dream. Did you see it? No. It's cool.
So, of course, along the way, we do have to kind of have the ship follow us as we are doing this
So that huge.
movement. Ship needs to keep up with us. So as we're scooting along, the pilots will send like a new updated coordinate or a waypoint to the bridge, and then bridge will navigate the ship over there, and that way we can make sure the ship's not falling too far behind. And when the pilots place that marker, they also want to make sure that the ship's not getting too close. Because, of course, ROV SuBastian, a remotely operated vehicle, it is connected to the ship by an umbilical tether. And we want to make sure that that tether, isn't in risk of getting kind of stretched out too far. And then there's just, more tether than you can easily manage. We also want to make sure it doesn't, go under the ship, for example. So, a lot of considerations.
We're spraying on stored energy kind of like AUPS for the switch and the media. That's how you got power taken from the power plant. Just having that connection, that just is a good
Wow.
all that.
That's amazing.
I'm going to test this one we have powered up to all the lights and everything working. We'll be off of
Well, that's fun.
to see how long that switch just ultimately, I know I'm not going to fuzzy that.
Alright, send the line. There's in 27.
So when we turn, you can see just how often that multi-beam is firing. You can kind of see in that little fan as we turn.
So I think we've already made the call. We will turn it on this time. The discussion now is the possibility of
Takes the flight.
Is this the delayed one? God.
That's all the slack you've got.
Oh, just. So,
Getting Juliana onto a mic here.
so I know many of you were following along with us on the last expedition. One of the last few dives we had was actually in Cocos National Park, which is in Costa Rica. We stopped there on our way to Costa Rica after our vertical reefs dive. And we did some pretty critical multibeam mapping from the ship prior to some dives. And there were 2 seamounts that we dove on in our short time there. And one of them, Himalayas 1, was a very seamount-esque seamount where you would actually see a peak and it kind of looks like an underwater mountain. And then we mapped for high resolution the first time on Himalayas 2, Himalayas 2. And we started off expecting to run the extent, so the outer edges, to see if there's any vertical reefs. And we were basing that off of satellite imagery. And so satellites can actually, over time, take images of the Earth, and by measuring very, very small heights in the water over time, it can then deduce seafloor imagery or seafloor typography. The idea of that is anytime there's a feature there, its small gravitational pull will actually build a bubble of water slightly higher than the surrounding water. And so if you have very, very fine scale measuring, you can actually, based on the average height of seas, you can get a very, very rough estimate of the topography down below. So that's how Google Earth is measuring a majority of our oceans. If you ever took the time to really zoom in on the ocean on Google Earth, you'll see all of these spider webs and lines, and that's actually, for the most part, satellite imagery, and then you'll see lines every once in a while, and that's ship tracks throughout the ocean. And so ship tracks have multibeam, which is high resolution. And so when we were mapping for the first time Himalayas 2, we were quite surprised to find that it's not actually a mountain-shaped seamount. It was basically a ridge of several different hump features and mounds. So that was our last dive, was exploring that area. So it comes full circle to be able to see a really wide view starting from satellite imagery to then map it with our ship's multibeam, which will give us, about 10, 15 meter accuracy. And then to go right from that to this cruise where we're talking centimeters, it's going to be very, very cool to see.
Yeah, I mean, that's the thing, right, is that resolution is, kilometers in some cases for the satellite mapped sections. And then it's still, it's still meters, tens of meters sometimes. And so you can really miss those finer features. Something like a chimney isn't going to show up. But then you've got these finer systems that can be mounted onto, an ROV, sure, but we could also mount them onto an AUV and say, hey, go explore this area. And then we get to see all those finer features, the chimneys, or honestly, when we're measuring centimeters here, we could probably say, there's a clump of worms.
Yeah.
Figure that out.
Yeah, and I was quite surprised when we were in Galapagos. Not a lot of Galapagos has been multibeam mapped. So I live in Hawaii, and all of the islands have been ad nauseum mapped by researchers there. And so that's kind of what I was used to seeing around islands. But it was quite interesting when we were doing mapping projects on the last cruise around the islands themselves. A lot of the navigational charts were lower accuracy, and we found that a rock that was out of the water was actually in a different location than the charts were saying. So it's really critical to not only understand the very, very, very fine scale mapping, but also to map the majority of these oceans as much as we possibly can, which is what we're out here to do.
Yeah, the stuff like the Google Earth or the satellite achieved mapping is like it's good because you can see general features. But also, then when you're talking about the importance of getting high resolution, a lot of times you're talking about the importance of mapping the ocean. And people go, well, I can pull up Google Earth and like there's a map right there. It's like, no. Like we want a usable map because Google Earth isn't trying to let you navigate the deep sea.
Yeah.
Right? Google Earth is presenting the data that is there. But I mean, Google Maps navigating land. Right. And so if we want to navigate the deep sea, if we want to be familiar with it on a scientific level, just like you might be familiar with the ocean or with the land from like a street view level through Google Maps, in order to achieve something like that, we do need these mapping projects to go out and get fine resolution maps of all of these areas.
Yeah, I mean, it's often the first thing we do when we arrive at a site. We first map it and then do a C2D and then we dive it. So mapping is truly the one of the baselines for the start of research. And the more you can understand an area, the more you can see it, you can then understand it. And then that'll help us figure out ways to protect it.
Mm-hmm. Yeah, a lot of times the scientists know there's a seamount here. We know that much. And then we go and we map it and we figure out the terrain a little better. And then the ROV dive can be planned around that, right? So for the vertical reefs expedition, we're looking for vertical faces. Mm-hmm. We know there's a seamount. We think it probably will have some vertical faces, but we have to go and map it to figure out where actually are like the steep cliffs. And then from there, we can plan our dives. So yeah, it's an important step.
Anything interesting shows up.
If you are just joining us and you're like, what are they talking about? And what is on my screen? We are actually mapping right now with the remotely operated vehicle SuBastian. So you can see on the right side of your screen some of the data from the M3 multibeam unit mounted actually on the back. I haven't shown that yet. Let's see. So this is the little
Yes.
mount that we've got on the back. Here we go. Let's see if I can put that up there. Oh, wrong one. There you go. So this is the camera looking out the rear of SuBastian, and usually like we bring this up during recovery, and you can see the umbilical there, or you can see like the lights from the ship. But normally there's not too much in the lower right. And so that's actually a little bracket that's off the back of SuBastian right now, holding this multi-beam facing downward so that we can basically map as we drive. I think what's fun as well is we kind of saw some of it last time, and we might see some of it this time as well. Last time being last expedition, excuse me. But talking about photogrammetry as well, and getting these very high resolution 3D models of the terrain or of objects on the seafloor. And so being able to combine the high resolution mapping with photogrammetry is really cool. It's like there's photogrammetry used in Google Maps, to bring it back to that, right? Where some cities have been modeled a little bit. And so the buildings have like some 3D to them. And some of that's just straight up modeled, just regular CAD models with some textures on them. But they've been working with photogrammetry as well. And I think it'd be cool if you could zoom in on Google Maps into the ocean and, go to like a vent field and see the little photogrammetric models of the vents that have been actually modeled. So that'd be an ideal thing for mapping, I think.
Yeah. To explain what you're looking at, on the right are two different displays from our M3 sonar. And on the top is what we call a waterfall view. So we're looking kind of as a perspective from the ROV, and you're kind of looking from the top down at the topography that we're mapping. And so with each line, you'll see a subtle line added every few seconds, and that's what builds the profile the last few minutes that we've flown over. And then on the bottom, the amber display, that is basically a view of the water column from the echo sounder down to the bottom. And that amber lighter area is it's detecting the bottom there. So you'll see that change with the topography that we're flying over. So the very subtle humps and divots there will actually relate to the fuller picture of the topography on the top.
End of line.
So we're about to turn, and that'll make it real obvious. There you go. So that's the ROV turning. You see the fan. And so now you can really see that real-time update. And as Chris studies out the heading, it'll start building a better picture without those gaps.
Okay, you can basically see like at what frequency that scan is happening as we're turning.
So a lot of multibeam mapping comes down to the sonar you're using, and that just comes down to frequency. So frequency is pretty complicated, but in general it's a simple concept where the lower frequency you have, the farther you can reach. However, you don't pick up too much resolution. So I picture it as like a wavy line where it goes pretty far in, but you're not coloring a huge page with the amplitude. Whereas a higher frequency multibeam, it will have a higher peak and trough, and so you won't be able to go as far, but you'll be coloring in a lot more of that smaller area you're mapping. So Falcor 2 has 3 different multibeam sonars. We have EM 124, which is 12 kilohertz, and we have 712, which is around 70. And so that's our deep and medium multibeams. So our 124 will go full ocean depth into basically 11,000 meters. But that's super low frequency, 12 kilohertz, and so we lose a lot of the small details in that. We get a lot of coverage, but all of those small details are lost. Whereas the M3 sonar is 500 kilohertz, and so it's very, very shallow, so you have about probably 50 meters, maybe a little bit more, of range, but you're picking up so much of that fine detail from that higher frequency pings.
Yeah, and part of Juliana's job here as the marine tech is sort of selecting, like, yeah, it's looking at what we're trying to achieve, selecting the tool for it, right? What system are we going to use? But then also looking at the data that is being produced, and you got to clean it up sometimes, right? Because we get little bubbles or whatever else. And we've talked about in the past, and folks have seen it, right? Where we have an old map or something, and there's like a shadow on it that looks like a peak, or it looks like a hole. And so part of your job is sort of figuring out like what is the data and what are little anomalies, and trying to clean that up.
Yeah, depending on the science party, we'll either just be completely in charge of mapping, or we'll work with the science party for mapping. And a lot of times the science party, like this one, brings their own mappers with a lot of experience, and so we learn a lot from them. But yeah, processing the data is really an art, and being able to pick out what's noise or what's some errors from the turn data, or what's errors from your navigation data as well. So people who have a lot of experience looking at this kind of stuff can pick it out almost immediately. So in our M3, that real-time display there, we have a lot of heave artifacts. So what that means is heave is when, on a ship, it's when it rides up and down a wave. So it's a vertical movement. And the ROV is also doing that a little bit as it's flying, not too much. But when we post-process, and when I say we, I mean the scientists, they were just talking to us about how they added the sprint INS position, and they corrected for that. And it basically filters all of that wavy texture you're seeing in that top display. So a lot of post-processing can clean up the data to have it be a really beautiful high-resolution image.
Got a little squidworm there. We've seen a couple squidworms. You might have heard Juliana talking about heave there and wondering if the seas are rough. No.
Nope.
Nope. It's just the sea. And we are floating in it, so we move around. It is a little overcast out there. I don't think it'll be interfering with our internet, but fingers crossed. And if it drops out a little here and there, please just have patience with us, and we'll work to get our signal back to you. But that's the weather report. No weather birds today. Although we have had a lot more birds, just like the past couple nights on the way out here, than we had for all of last cruise. And I think that, like last cruise, we were usually within visual range of an island, and the birds just said, I'll go home. And they just went back to the islands. But I think when you're out in the open ocean, they really just see the ship and they're like, all right, I'm going to go hang out there. So we have more.
Yeah, it's quite frustrating.
How do you feel about the birds? Let us know how you feel about the birds, Juliana.
Well, we have time, that's for sure. But the birds really love our foremasts, which is where I have all my MET sensors.
Meteorological sensors.
Exactly, yeah. So we have some sensors to give us wind, precipitation, light, how much sunlight there is, pressure, temperature, and the birds affect all of that. So
it looks like maybe there's one out there right now.
Yeah, there's not too many. During the transit, we had quite a lot of birds.
There's a couple.
Yeah, they're all on my sensors. Yep. But, yeah, we can all cohabitate.
You can tell, though. Like, the other day, you were like, there must be birds on the mast.
Yeah, a lot of our sensors on Falcor 2 is we have dual sensors. And while that's a lot to keep up and maintain, it's actually really good, because when one sensor starts to drift, you can then immediately notice it and say, like, oh, the wind is not great from this one sensor. And then usually you go up to the foremast to investigate that. And oftentimes it's just because a bird's sitting on it and it's blocking the wind, so you can see it pretty immediately. But from a data quality standpoint, it's difficult to explain birds as they come and go.
You might have to stop the vessel, get ahead of them, move the vessel.
Seeing here the pilots discussing potential maneuvers with the ship here. We are, of course, having the ship sort of follow along as we are moving. And so just keeping in mind where the ship is and how it might interact with our movements is really important. So there's a little conversation going on in the background about that.
I can't believe you've been talking this whole time with the Echo headphones.
Oh, yeah. No, I've got the Echo headphones on.
How can you do that?
So if you're like, what's Juliana talking about?
They know. I completely know.
Okay.
No,
well,
you can explain.
If they don't. All right. So multimedia technician, right? My job is to make sure the stream gets out. I also do like ship-to-shore connections with school groups and that sort of thing. But when I'm monitoring these streams, I need to make sure that the audio is going out, and I need to try and balance mics and cut mics in and out. And there's two headsets. There's a headset you can wear that you can hear yourself a little bit, but as you're talking, like you just kind of hear your own voice.
That's what I'm wearing.
That's the one Juliana has. That's the one that's out there at some of the other microphones. And then there's the headset that I'm wearing right now, because Juliana has the nice headset. And this headset has, I don't know, like a quarter second. I had to click to hear it. Like a quarter to a half second delay on this headset. And so sometimes you'll hear me start talking really like slow or spaced out. And that's just where the echo catches me off guard. But you can get used to it. Juliana can't get used to it.
Let's swap. Let's do it. We'll do it.
Let's swap. All right, here we go. All right, so I have the regular headset now, and Juliana's going to slap on the echoed headset, and we'll see how bad it is.
This is great.
Yeah? Explain what you do as an MT on the ship. I just need you to talk a little.
Yeah, so the job of a marine technician is basically, I have to take them off?
All right.
No, I can do it.
All right.
On ships, you have generally deck and engineering and interior departments, and they take care of that areas.
Would you like to swap?
No, I'm good.
You sure? All right. So Juliana's got the echo headphones on. It's basically like someone just talking over you constantly. You're gonna finish.
Yeah. We're gonna do it. Okay.
All right.
So for research vessels, we have a science department. And the reason for that is anytime you have a new cruise, you have to then integrate the new science party onto the ship. And so it's our job to be basically liaisons between the science party and the ship's vessel. How was that?
So someone says, like, do you need a better headset? No, not really. So the problem here is that the audio that I'm getting right now off the raw headset is just the raw mic audio. It's not run through any filters. It's not run through any like noise cancellation or anything. It doesn't have a delay, so you can talk over it just really easy. You're just hearing yourself talk, but without a delay. It's not bad. But the ones that Juliana has on actually have the filters that we apply and the noise cancellation. And so just making sure that sounds okay is one of the tasks I have here. And so I wear that headset just so that I can make sure levels are sounding all right and that the filter isn't just knocking everyone's voice out, but it's at least letting, the person at the mic through. Because it's being run through the filter, you're intrinsically just going to get that delay. And you could get mixers, for example, that you can put filters on and then you're not going to get that delay. But because we're piping everything through the network several times as part of getting the stream out there, I just get a little bit of a delay. And it's all right. I make do.
I can do it if I have one ear in the headphone and one ear out.
Yep.
That I'm not listening to me talking in the echo.
Yeah, and that's usually how I'll do it. But that also just lets me hear other people in the room as well. So.
Yeah, I was just impressed.
She still has the headset on.
That you can go on for so long with
just the one headset. Yeah.
Yeah.
Well, it drives Juliana crazy too because when she would come relieve me for the dive watch, I would just get up and she would just take the headset that I had, which is the Echo headset, every single time.
Every single time.
So she is finally just marked the headsets of which one was the Echo and which one is not. So. Actually, soon we're going to have just a single headset, and I'll be able to toggle back and forth between inputs onto that headset. And so then I'm sure that'll still confuse people because it'll be toggled onto the Echo probably. But. So yeah, there's a lot going on here. If you're curious about the whole streaming operation, basically, we are just using streaming software that folks like to use for streaming games or streaming like video podcasts weekly on YouTube and that sort of thing. And then we also have a network in the ship. Sometimes you'll hear folks refer to it as like our video matrix, or you'll hear like the brand name Everts. And it lets us, any computer that's hooked up to Everts and any monitor that's hooked up to Everts, we can path any of those to each other. So we can take a computer that's like down in the very bottom deck, and we can pipe its controls and its video output up to a screen all the way up on the bridge if we want. And so our recording computers are actually the deck below us right now in a little server rack down there. I'm interacting with them on a monitor in front of me here in Mission Control, and I also have set up little button pads here that I can send signals from the various computers and cameras around the ship to those computers where they get picked up. And then we use the streaming software to just push those out to YouTube and Facebook. And we have satellite internet because we're at sea. But most of the time it cooperates. Every once in a while it gets a little wacky, but most of the time it cooperates. So I'll trade you back.
Wait, we're still okay.
All right, there we go. All right, back to my Echo.
Oh, sweet relief.
All right, if you're joining us, we've been streaming just a little over an hour.
I don't like the sound of my voice.
And we are, let's see, I don't know, how many lines are we doing total, do we know?
All of them.
All the lines?
28 or so?
28 or so? All right. Do you know what we're on?
13.
Okay. So we're going to continue on with our lines here, just mowing the lawn, doing this survey up about 45 meters off the bottom. And then afterwards, when we're done with the survey, because we have the InSAS, we have the magnetometer going on these surveys, but we're actually going to do like a visual survey as well. We'll drop down, we'll explore, and we do have various sample targets, sample objectives.
Alex, we should be done in about 3 hours.
3 hours. All right, well, you've heard it now from John. And that's not done with the dive. That's just this mapping portion. But there is something kind of calm about it. It's more of a road trip than off-roading.
That was beautiful.
Get out. So we are still above the equator. For folks kind of try and follow along where we are. For last cruise, we were below equator by like 0.5 or something for a lot of it.
We were crossing it.
We are going to be crossing. We're going to be going. We're at 0.80 north right now, and we're going to be heading south from here. We're headed back towards the islands. So we will be crossing the equator once again.
Have you gotten your shell back yet?
Not yet, no.
Uh-oh.
You know this.
What does that entail?
What does it entail, Juliana? Juliana has her shell back.
So, back in the day, sailors would celebrate monumental crossings of certain landmarks, like the equator, the dateline, or the prime meridian. And oftentimes there's a tradition that if you cross those, you take part in a ceremony. So the ceremony is shrouded in mystery by default. And generally, those who have crossed the equator, otherwise known as shellbacks, force the people who haven't, otherwise known as polywogs, to go through a series of tasks that will remain a mystery. You know, and it's part of the process of becoming a seasoned sailor. And I hope you get to experience it soon.
Now, you have yours. Where did you get yours?
I got mine on Falkor Classic, crossing from, we did an ocean transit from Majuro, Marshall Islands, to Honolulu.
I thought you just joined the team this year. What were you doing on Falkor Classic?
I was actually the first student opportunities intern back in 2015. So they brought me on board, and I shadowed the science party, and I ended up shadowing the marine technicians a lot because I really liked that. I also stood a bridge watch, and yeah, I spent a month on a cruise actually studying El Nino, so it's kind of full circle. And through that transit, we did a equator crossing ceremony.
There you go.
Yeah.
Cool. Got a real nice view of the waterfall right now on the M3. So you can kind of see, we of course have that false color applied to delineate different altitudes.
Mm-hmm. Yeah, your reds are shallow, and your blues and purples are deep.
Yeah. That's also an art in itself.
Mm-hmm.
We talked about mapping being an art. Applying a nice false color is an art.
Yes.
And a bad false color, it's just bad.
It also just pisses everyone off. Yes. But, yeah, depending on the color scale you use, you can adjust the range. So right now, a lot of the change is basically you're seeing a lot of red and a lot of blue. So that's a very common height for there. And then everything in between is kind of during that ridge area. And so if you adjust the ranges in either direction, you can manipulate it so it'll show you the color change where you want it. So we do that a lot for the ROV team to show small ridges as opposed to larger ones that they're immediately gonna come in contact with.
Mm-hmm.
But yeah, you'll find surveyors have
their own tastes.
They have very strong opinions, exactly. On which is the best color to use.
Just grayscale. Just do grayscale the whole way.
Absolutely not. No full blue either.
No full blue? All right. I don't know, grayscale.
You guys agree?
What?
Grayscale for backscatter.
Grayscale, of course.
Grayscale for
Sorry,
backscatter.
that is the only time.
If it doesn't look like the back pages of one of those Magic Eye books from the late 90s, where it shows you what the 3D image in the picture, yeah, always grayscale. you didn't talk about the all of the sonar systems. We didn't talk about the ground.
Yeah. So we have a sub-bottom profiler, SBP-29. That is even lower frequency. It escapes me this moment. But by having the lowest frequency possible, it will actually penetrate into the sediment. And different layers of sediment will send back some sound as it's reflecting. And so when you have the sub-bottom profiler going in sedimented areas, you'll actually be able to see layers in the sediment. And we had that running throughout the transit here, and we were getting really beautiful data. But as soon as you hit rock or anything that's a very hard top that's not sedimented, you'll just get really sharp returns, and it can't go into rock, obviously, but any sedimented area, and it gives you an idea of a geological history of that area.
Yeah. I mean, where and how much sediment is collecting is really important when you're looking at the history of an area geologically.
Yeah.
So being able to just see that with sound waves, it's pretty handy.
Yeah. It's pretty cool. The more information we have up here, the more we can kind of prepare the ROV pilots for what they'll find down there. So we use the backscatter to do that, we use the multibeam to do that, and we do the sub-bottom profiler as well to do that.
But also start moving to the east to get us set up for the next one.
We also have a acoustic
We'll set up the
water column profiler.
Right, yeah. We've talked about that a lot last cruise, but I can pull it up.
I don't think it's on. Oh, yeah.
We have that one. We don't have the ROV one. Right?
You're right. So, the Falcor 2's gondola was designed to be able to gather as much information from the water as we possibly can. So, of course, that comes mostly with multi-beams. We also have kind of like a dummy single beam that gives us a single beam below the ship. That's mostly used for depth, although for the most part we use the multi-beams as well for depth. Mm-hmm.
Is that on the UHDAS?
Yeah. And then we have current profilers, which are called ADCPs, Acoustic Doppler Current Profilers. Those they send out conical beams, usually 4 of them, and it detects the Doppler shift. So as an ambulance is going by you, you can hear the change of frequency based on the movement of the ambulance. We use that same concept to give us information on the current. So it will pick up the little particles of sea snow as they're moving, and the frequency shift from that will give us a profile of the water column below us. And so Alex just pulled up the ADCP plots that we have on display. There's 3 of them because we have 3 ADCPs. Again, they're different frequencies, so they're aimed for different depths. The one on the right is our deepest. That's our OS38. It's 38 kilohertz. And that it's actually going really deep right now, to about, if I can read, 1,200 meters.
1750. Oh, but the things themselves are getting down to about 1,200.
Yes. And so all of those arrows, if you look at where they're going from in that center line, if you imagine it as a compass, the direction of the arrow is the direction of the current. So that top one, at the top, the blue, that means that at the surface, or 100 meters is the first value, that current is going to the southeast, and the length of the arrow is the velocity of the current. So we have a strong southeasterly current at the surface, at about, I don't know, what's that, half knot. And then it changes pretty abruptly to go southwest as you go deeper. And then it kind of trails out towards 1,200 meters. This location where we're at is deeper than what we have. So it's really hard to get a deeper current profile than 1,000 meters just based on the frequency you need. But because you still need to be able to pick up small particles for that to function. And so this depth is really unknown to us in terms of current, but on the last expedition where it's shallower than 1,000 meters, we knew what we were dealing with the whole time. So we have ADCPs, and then we have what's called an EK80, which is basically a fish finding sonar. Doesn't just do that, but it's pretty cool. There's different frequencies as well. Those will give you different depths, and it'll allow you to track migrations of different fish or mammals in the water.
Yeah, we've shown in the past, like, you can actually see the migration of the midwater critters coming up and then going back down as the sun sets and rises again.
Mm-hmm. We also have hydrophones.
Yeah.
To listen. And they will listen to a wide variety of frequencies. So that Sebastian's loud. But we didn't use the hydrophones for that. We actually, on the last cruise, had a lander, which basically had a GoPro in it. And that gave us sound. And let's just say I'm surprised we see anything down there.
Yeah,
because of how loud Sebastian is. No, we love her. We love it. She's great. She's just loud.
See if I can get this sized a bit better.
Oh, there she is.
So that's the view under the bow. So that's actually a view off of the gondola. So all these instruments that have been talked about, or a lot of these instruments that are being talked about, are in a kind of like a hammer-shaped gondola underneath the ship. And so we have a little camera on the front of that gondola.
The little square.
Enjoy more or less.
No. They share right there.
So, buddy.
I mean, if you like conversations about my phone,
I'm insulted.
So there's a view of one of the Voith-Schneider propulsion units. I think the feed's frozen. So let me kick it on over to the next one. See what we can see. Oh no, actually that feed is not frozen. Oh, I'm gonna leave this up. We'll see when it moves.
Look at the fish.
Yeah.
Is that fish?
Yeah. All right, I'm gonna leave that then.
They usually only operate one during dives.
Oh, okay. So I do have to kick it over to the other. So that's what it looks like when it's not moving.
I thought that was just the same frame rate.
I know. I thought it was just frozen. Yeah, but no, there's little fish moving around. There we go.
There we go.
So that's the other one. So that's the type of propeller that we have. We call them the egg beaters because they kind of just sit under the hull like egg beaters. And they can actually change the pitch of the blade just on the fly.
Just like an airplane wing.
Yeah, like changing the wing of an airplane or like on a helicopter. And so basically it acts as like a paddle wheel, but we can change what direction that paddle wheel is pushing by changing at what point in the circle the blade is against the water versus flowing through the water. And so that allows us to just move in any direction, basically, using our Voith-Schneiders. So really, really good at station holding because we don't have to be facing in any direction, really. We like to face in certain directions, but we don't have to.
Yeah.
It just makes life easier.
Yeah, this ship really likes holding station, and that's what it was designed for when it was the Polar Queen, and it would just stay in one location throughout different projects. That's why it makes it a good research vessel for us to ROV dive with.
oh yeah, continue on. Yeah, it's definitely.
Just keep going east.
Yeah. No, we have the waypoint set up further east, about another 220 meters to your east. Can you see the possible waypoint?
I'll probably have to zoom out.
Yeah, I've got that.
Alright, thank you.
So yeah, if you look carefully, if you kind of follow one blade around with your eyes, you can see there's a point where it kind of changes its angle a little bit. And so that's the point at which it is pushing against the water at that point, instead of just cutting through the water. And we can change at what point in that rotation the blade turns. So we can tell it to push against water at any point in that circle, which is actually pretty cool. And it's not that complex a mechanism that changes the angle. I actually saw a little diagram of it, or a little 3D animation of how it works mechanically, and it's pretty simple. Quite impressive. These type of thrusters, smaller versions of them are also used under like tugboats and tender boats that need a little more maneuverability. I want to say some ferries will have them as well, just for ease of pulling up to a pier.
So the way we have the M3 oriented right now on our screen is a nice waterfall view. It's called waterfall just because it's like it's trickling down and we're kind of looking at it from afar. But forward or into the black is where the ROV is headed. And everything, if you could picture the ROV right where the black and the color is, everything that's colored is what is just behind the vehicle that we're mapping. So our scientists are pulling in each line of data as we go, and they're looking at it and able to make sure we have a full set of coverage, and make sure that we're not causing holes, and making sure that the data is looking good.
Yeah, that is an option. If you want. If we had to stop and just pause for a second, we'll just stop recording or stop pinging.
We could just stop the file.
I didn't know you'd want to stop a file on a line or not.
Still moving forward? Still moving forward, okay.
We are now, but
You okay?
yeah.
We're going forward. I think it's just this. What is this?
I'm just saying if we did want to pause, we could just either stop recording. But would that create a new line then for that?
We'll create a new line. Which is not a big
It
deal.
doesn't matter. Okay.
We'll stay a little data already drifting forward.
I mean, we could even reverse a little
We
bit.
could reverse a little bit.
Yeah. Okay.
Do you want to do that?
So we're actually on one of the longer legs of this survey. And they're just kind of talking about if the ship's keeping up with us, and talking about talking. Or talking about talking.
There's
Talking
not
about
very
stopping. There is a lot of talking about talking sometimes, though.
Yeah, with me.
And then you want to reverse 5 meters, 2 meters. And just do that same.
So we're just pausing to let the ship catch up, and then we'll be back on our way.
How are you doing that? And Brady display, is that just two separate pips?
No. All right, we're going to have a little bit of a watch change happening here. Sounds like we're going to have J-Rod and Carl jump on.
"12-hour shift has 4 pilots. So there's like A and B, and they just, yeah. Mm-hmm. What's that? Oh, yeah. Yeah. It's just anything past 3 hours sitting in a seat, you start losing stuff and getting tired, and yeah.
For folks joining us at home, we're almost 2 hours in to this dive stream. This is dive 603, and the first of the dive streams for the current expedition, conducting ultra fine scale seafloor mapping along the Galapagos Spreading Center. We are continuing with some mapping. I think we're over halfway with the mapping. We got a little bit of mapping done before the stream was fired up, just making sure instruments were going and everything. But we're going to continue mapping, and then we will drop down and explore this area, which is a hydrothermal vent site known as Rose Garden. First discovered in the 80s.
Do you know why it's called Rose Garden?
In my head, it's going to be because of the tube worms. Maybe a lot of tube worms. Or a lot of cool layered lava stacks. When they collapse down on themselves, sometimes they look like little flowers or roses.
Yeah.
Yeah, I'm gonna have to look it up. So believe it or not, there is a website where you can look up hydrothermal vents. It is vents-data.innerridge.org. It's also called the Vents database. And they're not all in there, but if you're following along, a lot of our dives are in there. And it just gives you a little bit of information. Yeah, this region is part of the area where hydrothermal vents were actually first discovered. But I believe that Rose Garden itself wasn't. It might have been discovered late 70s, but it looks like it was kind of first detected late 70s and then first explored perhaps in the 80s. Yeah, Rose Garden vent site itself discovered 1979. So there you go. Someone wants to know what the pressure is down here. So we're at 2,417 meters below the surface, and it goes up by 1 atmosphere every 10 meters. So currently we're at 241 atmospheres. Oh, J-Rad's going to give me the exact pressure.
CTD is reading 24,000 decibars. 2,400, sorry, decibars.
2,400 decibars, yeah.
You want me to convert that to PSI?
Yeah. All right, so according to the Vents database, this was indeed part of the 77 discovery. They knew there was a plume, and they had photographs of clamshells. And they named this vent field Rose Garden at that time.
Thank you.
But the actual vent site itself wasn't discovered until 2 years later. In 1979. So. But they knew there was something here by doing some towed photography. So basically towing a camera in 76. They visited the site famously in Alvin in 77. And then this particular vent site was in 79. It's an exciting area to visit for sure. Yeah, it's been visited multiple times over the years. It looks like, at least as recently as 2002, it wasn't active at that time. And I believe we're expecting to find it in an inactive state, or perhaps just low temperature venting. Yeah, not everything's on Vent's database, but I like pulling up as we're diving, kind of pulling up what we were looking at. So interestingly, yeah, there's a bunch here in the area. We've got clambake, dandelions, Garden of Eden, musselbed, oysterbed, rose garden, and rose bud are all vent sites here. Oh. We got rose garden and rose bud. But Garden of Eden is apparently 6 miles out of here. Like, it's pretty spread out.
We may visit Garden of Eden later this week.
Oh, okay. If you didn't hear John there, we might visit Garden of Eden later this week.
John, is there a process of naming vents? Like, do you...
No, it's chaos.
It's chaos. Do you have to, like, map it? Do you have to be the first person to discover it? Do you have to sample from it? Is there any guidelines?
There are no formalized rules for this, but the generally accepted rule is the first person to lay eyes on it, either with a submersible or with an ROV, earns the right to give it a name.
Okay.
Some people have given names to vent fields based on detecting the plume.
Yeah.
Other people have then come to the site, claim they were the first to actually see it, and then give it a different name.
So it is chaos.
Oh yeah, chaos.
Then some people name it but never publish it, so somebody.
Yeah.
I was gonna say, how do you get the word out there? I guess just by publishing.
By publishing, yeah.
Yeah, so it looks like Rose Garden was used all the way back in 76, and all they did then was detect plume and get photographs of clamshells. So they knew something was here, but they didn't, like, lay eyes on the vent.
Rose Garden was named in
79, okay. I'm just going off the database. What was it first? Clambake. Is Clambake not a separate vent site?
No.
Oh, okay.
It's just,
Within the same field.
In the same field. Okay.
because people will, there's a vent field, and then there are vents within a vent field, and people will give individual vents a name, and then other people will use the name of the vent field, and then that's another source of confusion.
As obvious here as I'm like, there's a vent site called Rose Garden and a vent field called Rose Garden.
Yeah. Well, they eventually just extended the Rose Garden a whole area.
Okay.
But then at the end, you'll see that the Garden of Eden. Many people think it's another field.
Yeah.
It's so far away that I would.
You think it's another field, Garden of Eden.
Because the underwater, I'm plumbing underneath, it's serving it.
Yeah.
Separate. So vent fields are defined by what's plumbing?
Amy Gartman and I tried to write a paper to really define this, which we published in 2020, and all I did was make enemies from that, so... including Verena, apparently. So. The purpose of that paper was it was published in Marine Policy. It was because, for seafloor mining and all that, you have to come up with a definition for what it is you're going to mine. So we tried to formalize from a legal standpoint using geology as the basis.
Okay.
Anyway, apparently not very successful.
Even the geological literature disagrees with what you decided.
Oh yeah, yeah,
I know.
absolutely.
So, which is what I follow the precedent, because I felt there was a lot of precedent. It's not that important. As long as you define it in the paper that you're writing us.
But we were trying to define it for the lawyers and the policy makers, which was a mistake from the beginning to even attempt to do that. Anyway, everyone should read this paper.
Oh my
it's really
gosh,
good.
I can't wait to read it.
Nah, it's boring. No, I can appreciate why you did it. It's fine. I mean, even the database mixes the terms.
Yeah, it's all back and forth. It's a mess.
It's chaos.
At least we know how far they went. That's just going to waypoint 36.
So starting line 35?
Oh yeah, starting like 35, yeah.
So have you guys been at this location before, or just through the eyes of Alvin, or?
I don't think any of us have physically worked here
Okay,
before.
fascinating. Welcome.
I mean, we are diving on the spot. That was the first discovery. It's a really historic spot.
So is that here?
Yes.
Ah.
You will be visiting the cleft. That was the first spot. Kind of sinking heart, but there's nothing, probably nothing there.
Yeah.
There was some jacks there.
Shells.
Are you willing to talk about that first discovery? Into? You don't have to, but I'm fascinated, and I'm sure everyone else is.
Yeah, that's how
It's better than birds.
It's better than Mike's, that's for sure. You don't have to. It's pretty sensitive, so you don't have to.
I didn't do anything. Okay.
We haven't seen anything in about 3 hours now, so we're gonna shut it down.
It will be, yeah.
And then come back midnight, is that correct?
Yeah, so we'll be visiting the vent site that was set all of the science for hydrothermal vents and all the excitement in action. And it was the heat source above it was detected 1976 or so, but the first eyes that were laid on it were in a dive in Alvin from Woods Hole Oceanographic Institution in 1977. So that was a group of scientists from Woods Hole who were diving because of the prediction that there may indeed be hydrothermal circulation under the crust. And that was a prediction from a couple of decades ago. And they were interested in the idea that maybe this might affect the rocks and heat release from below the crust and the magma. And so they, put their thinking caps on, and if they could find a cleft, which was really well defined in the mapping at the time, that would be the right place to go where the heat would be coming out. Now, they had no inkling that there might be anything else other than a geological and hydrological interest at the time.
Yeah.
So when they dove in an expedition led by Bob Ballard, they discovered this site, which at the time they called Clambake. And there were some other little vents along there. There was oyster bed, there was dandelions, and what they hadn't anticipated was that there would be some strange biological communities there.
Yeah.
So they were just blown away by what they saw, and then they put another expedition together with more scientists from Woods Hole and a group led by Fred Grassley, who's a fantastic deep-sea biologist. And they came back the next year to take advantage of the biology there, and so the next dives were made. And that's and then the idea of the concept of rose garden came out because of the tube worms that were there, the giant tube worms with the red plumes coming out of the top, and so they dubbed it Rose Garden. It was actually the geologists that came up with that name. So they're poets at heart,
beautiful.
you know. So for us on this cruise, it's just really nice that we are visiting the place that was the start of all of the work in hydrothermal vents that happened, because not only was the biology absolutely amazing, we can talk about that later in the cruise, but just understanding the chemistry of the vent waters themselves and how that affected the formation, the water above it, and then subsequently it affected the oceans, but also the geological structures and how that was relevant. And so in 1979, the French were working on the East Pacific Rise, so several hundred kilometers north of here, and they discovered the first black smokers on the ocean floor at that time. And so for many decades, people thought, well, maybe 2 decades, people thought there were no high-temperature vents at Galapagos. So after a while, the interest all moved to other places that had these high-temperature black smokers. Lots of work at the East Pacific Rise. Then groups I worked with were discovering hot vents up in the Juan de Fuca Ridge. And the interest in Galapagos began to wane a little bit. But then later on, the black smokers were discovered, and we'll be seeing them later in our cruise as well.
How amazing. Thank you.
Yeah. Oh, look, he's going back.
I have the paper.
Good for you.
That's really cool.
Is that Corliss now?
Yeah. No, it's part of some package.
Yes,
Apparently.
yes. That was the republication of it.
I wanna
And the
read
25th anniversary. Yes, it's a really nice paper.
That's the paper on the discovery.
Yeah.
Yeah. So that's the.
Excuse me. Sorry.
1970s.
Thank you so much.
That's okay. We can take that back.
So this is it.
Yeah.
Interesting site.
This is the site.
What I should have said.
I had no idea.
Made them see me dancing there now.
It's there in our hearts.
Yeah.
We'll see. We'll see what's there.
So to clarify, that's here or close by?
We're flying over that area right now.
Okay, we're mapping that area.
But
I had no idea.
What's really, if we get down there and there's nothing there, what happened was that came back in 2002, it was still there.
Mm-hmm.
Came back in 2012, and all that lava that we saw when we came down, I don't know if you remember.
No.
So it's black glassy lava everywhere. There was an eruption at the site, and it wiped out most of the vents. There was a little bit of trickle, there was some left, and that was called Rosebud.
Oh,
Out of
gotcha.
Rosebud. So somewhere between 2002 and 2012 was some eruption.
Okay.
Then they came back into 2015, and the amount of venting had gone down, and it wasn't a whole lot left. So that's what I'm worried about, is that we get down there.
Yeah.
Or gone.
Yeah. Thank you. So, what she was just saying is, between 2002 and I think 2015, 2012, there was at some point an eruption that had covered the area and diminished a lot of the hydrothermal venting in this area. And I believe there was still a few spots, and that's why they called it Rosebud instead of Rose Garden, because there's a little bit remaining, which is so poetic still. Yeah, and so hopefully we'll, map it and see what's there, and it's part of the geologic process for things to come and go, and we'll see what we find.
So it's maybe entirely. And this is what we.
One thing that's a neat addition to Verena's story is that geologists had actually predicted that these vents should exist because there's, on the continents there's old seafloor, right?
Yeah.
The tectonic processes, it all gets smushed up, and so you could be in the middle of North America and you can, all those pillow basalts we see on the seafloor here, they're preserved, and there are areas where they found deposits that are exactly the same as the black smokers and the mounds, and so. And these are mines on land now. This is where we get copper and zinc and gold.
Oh.
And so geologists thought these things, and through the geological process, you could understand that these formed at the seafloor. And so it wasn't a huge surprise when they were finally discovered on the seafloor. What was the huge surprise was all of the animals.
Yeah.
No one, I don't think, expected that at all. They just expected fluid coming out of the seafloor. So it was some ways not a surprise. In some ways it was predicted, but then certainly from the biological point of view, it just changed everything we knew about how life exists.
Yeah. Can you explain that in a simple version for our viewers of why they were surprised to find life there?
You're asking a geologist,
Yeah,
a biologist question. I could, if I dumb it down enough so that I understand it.
Yeah.
Up until that point, as far as we knew, life depended on sunlight as the ultimate source of energy, photosynthesis. That was the basis of life, and everything built on top of that.
Yeah.
And of course, down at the bottom of the ocean, there is no sunlight, and so there was any life at the bottom of the ocean was thought to, through the food chain, come from the surface at some point. But this was clearly not like that, and in this case, the animals, the tube worms, and the microbes that live in the tube worms, that energy was being pulled out of chemicals in the fluids coming up from under the seafloor. So instead of photosynthetic-based life, you have chemosynthetic-based life. And my understanding was that was completely new to science at that point.
Yeah. I remember learning about that in science classes, and specifically of Galapagos, so it's fascinating.
Can I get an amen from the biologist for that?
I was gonna say. How'd he do?
Thanks, Verena.
When we were, I believe, the East Pacific Rise a few cruises ago, one of the big things we were trying to determine is if there's life beneath the vents. And so they started off with this, basically a box where they put it on the seafloor. We sealed it with the ROV, and we're like, okay, we're going to come back later, see if anything comes up from the rocks and forms in this area. And the actual experiment that they planned failed because the box created an anoxic zone, and everything died in there. And so they were kind of like, what do we do now? And they had our ROV pilots with chisels, and they just wanted some rock samples, and we ended up breaking off this huge piece of rock accidentally, probably like this big.
Like a pizza box.
What's that?
Like a pizza box.
Like a pizza box. And one of our pilots was like, well, do you want me to turn it around? And they were like, yeah, sure. And by turning it around, they looked underneath the rock and saw Riftia tube worms inside. And then from there, they were able to realize that there is most likely more research has to be done, but evidence that these animals are being transported within the low temperature venting water throughout the plumbing of the hydrothermal vents. Which,
I mean, that was such a great story.
Yeah. Yeah.
Also had been predicted.
Yeah.
But nonetheless, just really cool that you guys were able to do that. It's fantastic.
Yeah.
I was really excited. Yeah.
Well, it was fun too. It's one of those things where like the experiment as designed didn't work out, but they were like, well, we got to get rock samples anyway. And then in flipping this rock, like they literally opened a skylight, right? Like we see these skylights, but they found like an area where it was pretty sealed up, and they just worked at it with the chisel and managed to actually like pop the rock out. Yeah. It was great. And then you had like little tiny worms under there, and they were like, oh, that they were really excited about because you had these little worms. But then later they flipped a rock that was much closer to a clump of the Riftia, and like there were full-grown Riftia down, like spread out into the undercrust area there. So it was pretty cool.
Yeah. People have searched, including me, for ages up in the water column, dragging nets, trying to find the larvae of these animals.
Yeah.
Almost total failure, not complete. You get some, but just nothing to explain density on the ground. So it to be some of the things.
Yeah.
Something like a survey like this, we would have nets going on top of the sub.
Yeah.
So
Yeah. Like a little plankton toe on the sub.
Yeah, exactly.
Yeah.
They were exactly plankton nets strung out on the top. And then there's almost no larvae at all, so the few liquid larvae.
Oh.
Of course, that area as well had a similarity in that we were talking about sort of the eruption that has happened here that just wiped everything out. And there were patches there where the eruption was in like the last 10 years or whatever, I want to say. And you could tell like where it had been, but also the extent of it. And you could see like things still growing sort of at the edges of where it had been. But yeah, it's, you think of hydrothermal vents as being like this prehistoric thing, but they could be pretty ephemeral and just disappear one night.
Yeah.
Some are very long lasting.
Yeah.
Some have not changed since they were first discovered 30 years ago.
Yeah.
And some have persisted.
For sure, yeah. If you're in a chaotic area that's undergoing eruptions, then maybe.
I think the oldest known system is over 200,000 years old.
Wow. And is there signs of cycles to it, or?
Oh no.
It's another paper I wrote that really angered a bunch of people. There may be, but there may not be.
Okay.
It's a outstanding question still as to whether or not a vent or vent field in one location turns on or off over time.
Mm-hmm.
And it has sort of been accepted as truth that this is something that commonly occurs. And some of the work that myself and my group have been doing, one of the things we do is we date chimneys with radioisotopes, so we can figure out how old they are. And people have been doing this. This was pioneered by the French, and the Russians have been doing a lot of this. And we sort of, one of our COVID-19 projects, when you couldn't be in the lab, is we took all of the literature and every single date that has been created from groups all around the world, including our own, and sort of built a database and did a bunch of statistical analysis on this database. And our conclusion from these radioisotope age data was that these systems probably do not turn on and off over time. But that's just one line of evidence. There's not a lot of visual evidence because these sites, any one site is visited so seldomly. And as Verena says, most of them, when you go back, generally they haven't changed a whole lot. They're remarkably stable. Temperatures don't vary over a couple of degrees over a decade in some cases. But there have been documented cases where there's been some sort of volcanic event or seismic event, and then the temperature will have changed or the salinity of the fluid will have changed, probably because of magma rising underneath. So things do change in some cases, but whether or not they turn on and off is a very interesting question, which has huge implications for the ecosystems there, because if the ecosystem dies, and then when an event dies, and then an event turns on, then a new ecosystem forms, that means these ecosystems are quite young. Whereas if an event has been venting continuously for 100,000 years, then that ecosystem could be 100,000 years old.
Yeah. So we find a much higher diversity of animals at a site that John's group has dated on the one Fukablick Bridge. Diversity there is much higher because it's much older than the sites that we know have had volcanic eruptions. Middle Valley even more so. So Middle Valley and Endeavour, these are two sites that are in the north and have high diversity, really rich communities, and then further south, volcanic eruptions, much lower diversity. And we've been collecting over a long period of time. So well known. Except Middle Valley. So just a few collections at Middle Valley outstrips hundreds of collections we have from ours. So yeah. So is that Logitech is one of the sites?
Yeah, but the even older ones is Peterburgskoye or Krasnov. Those are sort of the oldest ones.
The Russian contact area.
Yes.
Got a question. It looks like the approach of the mapping, like we're at 45 right now, 45 meters or so off the bottom, but are we planning to get closer, or is this kind of the height that we're doing?
This is the height that we are doing using this system that we're using right now, this M3 multi-beam system. We're flying at 50 meters. This is sort of the ideal height in order to maximize the coverage area on the seafloor. But when we will be mapping with the SAS, the Synthetic Aperture Sonar, we will be flying much closer to the seafloor. We'll be flying at 15 meters. So we're at 50 meters now. With the SAS, we'll be flying at 15 meters. Unfortunately, in both cases, too high to see the seafloor.
Yeah.
But we should be in a couple of hours. We'll be heading down to the seafloor. So for those of you who are getting impatient, please bear with us.
I'd be surprised at 15. Sometimes the seafloor comes up to the sea.
Oh, okay. So we might get sneak peeks of the seafloor at 15 meters.
And what's the swath right now for the M3?
130. Craig, confirm.
So, about 130 meters off.
About 130 total across.
Total across, okay.
But our lines were overlapping So there's 50% of that is overlapping where we've mapped on the previous line,
Right.
just to ensure we get full coverage. So it slows down the mapping process, but we'll have a higher quality product in the end.
I think you just stopped. Okay, yeah, he's got it. Yeah, let us know when you said.
Craig, what's our total coverage area for this map?
600 meters in each dimension.
So 600 by 600 meters, and we started mapping at what time?
Starting 39.
11:30.
11:30, and it is now 3 o'clock, and we'll be done at about 5 o'clock. So close to 6 hours to map a 600 meter by 600 meter area. The resolution of these data when we process it will be a meter, sub-meter. So the size of each pixel will be less than a meter. And currently, the size of a pixel over this area is 50 meters.
Yes.
So that gives you a sense of the improvement.
And then we'll drop down to 15 meters and use the InSAS.
Correct. Probably not in this area, but
Okay.
we will be doing that throughout this expedition.
Perfect, okay.
The resolution of those data will be centimeter, like maybe 3 centimeter or so. So significantly higher.
Does mapping have any help to aging? Or is that just, you're just kind of building more of the picture of the ecosystem?
Yeah, that's a really good question. Yes and no. What we found is that we'll be going to some extinct sites on this expedition, and what we found is that the longer a site has been extinct, the less likely there will be upright chimneys, because they fall down. They become fragile as the mineralogy changes when they age. And so if you mapped a brand new vent field and you saw a lot of tall, slender chimneys, you would think, well, either it's active, or if it's inactive, it's probably somewhat recently inactive. Whereas if you come across a vent field and there are no chimneys, it's just smooth terrain, it is more likely that it's probably been dead for quite a while and all the chimneys have collapsed. So that's something we're testing, and it probably doesn't apply universally.
Of course.
But it is one thing that can help us.
Even trying to interpret lava flows.
Oh yeah, I think
It's really
even with the M3 data on this, I'm hoping you could see individual lava flows, and I think with the InSAS, certainly.
Mm-hmm.
We'll be able to trade the SAS.
Right.
No spires on this one? From what I'm collecting.
And then for the surveying, we also have the magnetometer on board, what are we doing with the magnetometer?
Chris, you want to explain this one?
Sure. So yeah, the magnetometer measures magnetic field. So the Earth's field is definitely the dominant field it picks up, but it also, there's secondary fields produced depending on the different rocks we're passing over. So whereas the bathymetry that we're collecting now gives us an idea of the shape of the surface, the magnetic data we collect will give us an idea of what kind of rocks there are underneath that surface. Just from one perspective, just magnetic perspective, but where this applies to hydrothermal systems is when you have the hot water, the hot fluids rising up through the crust underneath these, it destroys a lot of the magnetite. So you can actually map out in 3D the pathways that the fluids took up to the surface by looking at the decreased in magnetic susceptibility, which is the property that the magnetic field is sensitive to. So the data will be just a map. It'll look similar to the bathymetry map in 2D, and then I hope to take that map and model it to get a 3D model of what's going on underneath the seafloor.
Are you able to do it this time? Or is it better towards compound?
Magnetic field?
Yeah, it doesn't matter how.
Yeah, well, yeah, so I guess, like, hopefully, like, sort of the depth that you can model is a bit governed by the extent of the area. So the wider the whole map you're collecting, the deeper you can see. So it doesn't matter too much how high you are off. Yeah. So you're modeling, maybe 500 meters below. So if you're measuring 50 meters above the seafloor versus 40 or 30, that doesn't play as much of a factor. I don't know if you know. So, I don't know. I guess maybe the high temperature would maybe alter quicker. I guess in low temperature venting, you probably still have similar forms of alteration, just maybe not as severe.
So you would also see fossil.
Well, is it?
Yes, it is preserved. Yeah, it doesn't get replaced.
What's the Curie temperature?
Yeah, that's a separate thing. Well, the Curie temperature, so that's like if you take any, I guess, material, in this case rock, and heat it past its Curie temperature, there's just so much energy in the rock that the little magnetic moments that are responsible for producing those secondary fields are just vibrating too much. They just can't line up and actually make a field, so no field can be produced. So in the case with magnetite, which is the dominant magnetic mineral around here, it's about 580 degrees, which is way hotter than the hydrothermal fluids that we have measured. So you don't usually, it would be like a magma chamber would come up as zero susceptibility, but that doesn't play a factor with the fluids. So it's more that the chemical alteration as opposed to the physical change.
What's interesting is that there are certain places where normally you get what we call a burn hole of demagnetization, which you can see from the magnetic data. But there are certain conditions you actually get the opposite. You get more magnetization. So places where, here it's all basalt is the rock that's erupting on the seafloor. Places like the Mid-Atlantic Ridge, where your mid-ocean ridge, the spreading rate is really slow and there's not a whole lot of volcanism, and you end up, as the plates pull apart, exposing deeper mantle materials and beneath the crust. And that's an ultramafic rock as opposed to a mafic rock, which basalt is a mafic rock. And you hydrothermally alter that, and you'll actually precipitate magnetite as opposed to destroy it. So your map looks the exact opposite of what you would get pretty much everywhere else. So like all things, you can never apply these things universally because
There's a question for you, Chris, as well. Are we going to be collecting rock samples to more directly look at the magnetism, or?
We won't be. At least that's not the plan.
No, you're just using that magnetometer to sweep for it.
Yeah, but the modeling afterwards will give us the susceptibility.
Very cool.
Yeah, which could be double checked by looking at rock samples. But that wasn't the plan for this cruise.
Yeah, Chunk's biding his time, waiting for us to be near the bottom.
Chimneys here. Would there be any radon in the chimneys? Barrett? Is it barrett rich?
No, not that we know of. But we'll definitely check for that.
We were at least a few years later that radiometer went on. Near the chimney that Mark
Oh, yeah. We have a Geiger counter for us.
That'd be cool.
Oh, yeah.
I usually break one out. Anytime there's like any chimney material coming up, it's like, oh, let's check that out.
Oh, good for you. Safety first.
Yeah. I mean, what are we gonna do? It's not like, hook it back, but I'm just curious.
Remember you used to have the watches with the fluorescence on them? It was probably about
Yeah, the radium.
Oh, like dosimeters or whatever on that?
Looks so cool.
Yeah, the amount of radiation in these rocks is incredibly low, but it's enough that it can be detectable.
Yeah,
Geiger counter.
they're just fun.
So it just there's something about that sound from the old school.
Yeah.
That
Yeah. My dad was a nuclear physicist. Yep. Used to badge would go off.
Our artist at sea, a couple cruises back, had a lot of crushed glass on one of his sculptures, including some very old, nice green glass, and it was uranium glass. So we were able to take the Geiger counter and it's like, you can find it in antique shops. There's that, and then they used to use I can't remember what it's called, but there's like a ceramic ware basically that was made with radioactive clay. Shouldn't buy it, but you can find it in antique stores from time to time. If someone wondering the main thing you're looking to learn from that magnetic sweep of the area, they ask like composition, history, kind of a big picture. But you mentioned like it'll let us know where the thermal activity has been. Is that generally what you're looking for?
Yeah, sort of see where venting has occurred or is occurring. We probably won't get it in this field because the survey isn't large enough. But another question we could look to answer is connectivity between vent sites, because you can sort of see the hydrothermal upflow zones connect up. But just because this is a relatively small survey, we won't be able to see if this is connected to others, but more study where the venting might be occurring underneath the lavas here.
The biologists are all just waiting for us to drop down.
Are you able to give a brief crash course in why we have hydrothermal vents here from a geology standpoint?
It would be my pleasure. Why do you have hydrothermal vents anywhere? In addition to water, you need two things. You need heat, and you need permeability for the water to flow. So, bottom of the ocean, where do we get heat? We get heat from volcanoes and magma chambers below the seafloor. Where do you get permeability for water to flow through the crust is cracks, faults, fissures. So you need heat from magmatic activity, and you need fractures. So where do you find that on the seafloor? You find that along tectonic plate boundaries. There are two types of plate boundaries. There's the mid-ocean ridges, where the crust is spreading apart, and we're forming new seafloor, such as where we are right now. And then the other plate boundary is the opposite, is where seafloor is being destroyed, the subduction zones. One oceanic plate is forced underneath the other one and down into the mantle, and it's gone. Both of those tectonic boundaries, there's a lot of heat. Of course, at a mid-ocean ridge, you're pulling that crust apart and you're upwelling from deep. And so with that upwelling from the deep mantle, that's where you get heat, you get melting of the rock as it decompresses, produce magma, and that magma ascends towards the seafloor. You get these volcanic ridges, and that magma essentially acts as a heat source to drive circulation, convection. The process of the plates moving apart from each other is also creates a lot of deformation in the crust. These volcanoes, you're forming a ridge. There's a lot of processes happening. There's a lot of stress on the crust. We get faults. We get cracks. So here's you have your two ingredients essentially. You have your cracks, your faults from the rifting of the seafloor, and you have the heat that drives circulation, and that facilitates hydrothermal vents forming along mid-ocean ridges. Same thing with subduction zones. A lot of forces of one plate being forced up against another one underneath. That whole process of forcing one plate beneath another one causes, again, melting of the rocks deep in the earth. That heat comes up. You have all these cracks from all these forces, and then you get hydrothermal systems forming there. And then there's I guess a third flavor, which is interplate volcanism. So Hawaii is kind of a classic example. Off the coast of Hawaii, there are hydrothermal vents coming up from, and these are plumes, so these are hot spots, not necessarily associated with any sort of tectonic plate boundary. But again, that hot spot rising up, you get the volcanism, you get forces and pressure on the crust, cracks, you get hydrothermal circulation. Where we are right now on the Galapagos Spreading Center, it's we're on a sort of a classic mid-ocean ridge, but the Galapagos Islands are there because of a hot spot. And so we're right at this interesting juxtaposition of a hot spot and a mid-ocean ridge. Other places where we have this is the Azores in the Atlantic. And then Iceland is sort of a classic example where you have a hot spot sitting directly underneath a mid-ocean ridge, which is why Iceland is where it is.
Wow. So where does the black smokers come into play? Are they always present at hydrothermal vents?
No, the black smoke is associated with the highest temperature vents. So you could have a vent. You could have fluid coming out at anywhere from seawater temperature to the hottest hydrothermal vents, which I'm not sure if the record is 400 and something degrees, just over 400 degrees Celsius. Sometimes the vents are incredibly smoky, and sometimes they're crystal clear. And essentially that has to do with two things: whether or not there are dissolved minerals in the fluid and the temperature. So the black smoke the fluid is probably essentially clear when it's coming up through the seafloor, but as soon as it hits the seafloor and mixes with cold seawater, a lot of that dissolved minerals and metals in the fluid precipitate instantly because they can no longer be held in solution at cooler temperatures. So all that smoke is essentially tiny, tiny minerals, mostly sulfide minerals like pyrite and pyrite fool's gold. Everyone's heard of that. So the black smoke is just tiny, tiny particles that get wafted up with the fluid. Now, if the fluid has cooled beneath the seafloor or never got to a high temperature, either all those particles will have precipitated before the fluid made it to the seafloor. So by the time it gets to the seafloor, there's no more minerals in it, and so it's clear. That boundary is somewhere between sort of 200 to 300 degrees, give or take. So in some cases, you can actually guess what the temperature of the fluid that's coming up the seafloor might be simply by, is it really smoky, or are there just little whiffs of smoke, or if it's perfectly clear. And you can get white smokers too at sort of the 250 to 300. So there's not sort of a cutoff between white and black smoke. It's a gradient. But either way, anything below those high temperatures, you just can't have those minerals. And so when it comes up, it's just the fluid that's clear.
Yeah. And so the minerals precipitating out is what's building the spires?
Right. Well, that's an interesting question, because what is the fate of all those minerals?
Yeah.
The ones that are the smoke, those go up, and then they're in the water column. They're now in the ocean. Now, some of them might rain down right away because they're heavy particles, just like you get at a volcano. And you can see the accumulation of metalliferous sediments right next to chimneys. Other particles will travel further, they're finer, and probably eventually they will dissolve back into seawater. And so now they're part of the contribution of hydrothermal vents to ocean chemistry from these particles that have dissolved in seawater. And then another portion of what's been transported with these fluids will actually form the chimneys, and then ultimately you'll form mounds if the venting has been going on for long enough. So there are different fates for all these metals that have been transported up through the fluids. If there's mixing with cold water below the fluid gets to the seafloor, then you'll be precipitating these minerals below the seafloor. So one of the interesting questions is, these fluids are coming through and they dissolve all of these metals from deep in the crust and transport them to the surface. What is the ultimate fate of these metals and all these other elements? Does most of it end up forming the chimneys that we're going to see, or does most of it end up going off into smoke? And people have been trying to answer this question, and there's a huge range from 10% of it, or 3% of it ends up forming mounds and chimneys, and the rest of it in seawater. Other people at the opposite end, and it's probably site specific. There's no sort of one answer for every vent field. But it's certainly an interesting question, because we want to understand globally, how do hydrothermal vents contribute to the composition of seawater, for example. And answering this questions at one vent and then another vent and another vent, we can start to tie this together at a more global scale.
So when that water goes down and hits the magma, it's getting super hot, of course it gets to the boiling point. And is that when it's getting all the metals and everything, when it's in that boiling state and then it recompresses?
It doesn't necessarily have to be boiling in order to strip those metals out of the rock. In those conditions, it's probably at a temperature and pressure where it's a supercritical. So it's beyond sort of liquid or gas. It's in a phase where it's its own fluid, and they're temperature driven reactions. So if you have high enough temperature and the right chemistry of the fluid, low pH, that sort of thing, it'll react with the rocks, it'll dissolve the minerals and then transport them into the fluid. But then as the fluid is rising and the pressure is dropping, that's when it can boil. Right. And then that boiling process can then generate all sorts of different chemical reactions, because you then go from this fluid into a fluid and a vapor phase, and some of the dissolved chemicals will want to go in the vapor phase, and others will want to go in sort of the brine phase, and so it's what we call phase separation, and then the chemistry of your fluid is completely changed, because some stuff's gone that way and other stuff's gone that way, and
Making two different kinds
exactly,
of filled kind of.
exactly.
For the white versus black smokers, do you see a significant difference in the composition of those chimneys then?
Yes, because the composition of the chimneys is essentially tied to the temperature of the fluid.
All right, okay.
Because all of these different minerals precipitate at different temperatures.
Yeah.
So again, you could break off a piece of a chimney and look at the minerals and guess as to what was the temperature of that fluid based on that mineral assemblage.
And like the ones we see in Pescadero that are more like the overhangs.
The flanges.
Yeah, the flanges.
Yeah.
Is that from that same thing, just different kind of makeup, or?
I'm not exactly sure what results in the formation of flange. I'm not sure if that's sort of a fluid flow. These flanges, these big overhangs where they trap the fluid underneath them. Because we see them Pescadero, we see them at Endeavour, we see them some places, Loki's Castle in the Atlantic.
We saw a couple here, not big ones, but small ones that are off of the chimney, have the small flanges on
Right.
the side. But not consistent like Pescadero.
Yeah, no, I don't know. I don't. Anyone? Is there any flangologists in this room? No. We forgot our flangologists at home. Yeah, I mean, those are one of the coolest things you can see in a black smoker is these overhangs with inverted pools of hydrothermal fluid. But what ultimately formed, my understanding is it has to do with fluids leaking out the sides of the chimneys. And they leak out, and then they precipitate, and then more leaks out, and it precipitates, and it sort of builds out sideways like that.
Flow from initially built up at the high temperature flow, and then the diffuse flow erodes, or is it built?
I don't think so, because I've seen them flanges that, there's still a lot of fluid leaking out of the sides of them. So, and other ones that seem quite calm. So I don't know.
Some of the Pescadero ones look like upside down waterfalls.
Yeah.
Could it be just like a pressure change? Because we were watching, like, I think it was Brennan Phillips. He did that test with a fiber optic to measure the temperature. And so as the tides were changing, even with the moon, the pressure or temperature coming up was also changing with that, which meant the pressure was slowing down the flow.
Right.
Could that give it the cap off, and then when the pressure comes back up, it pops off a weak point and it starts coming off the side?
Maybe, but then why wouldn't you see them everywhere?
Yeah.
I don't know. Yeah.
And there's different structures, right?
That gives you more questions.
They're different structures, but they tend to commonly occur in certain places.
Okay, yeah.
Like, it's not just one odd chimney here. It's like this vent field is known for all of its chimneys have flanges, whereas that vent field over there, it doesn't.
Well, what? I mean, because what, you have flanges, beehives? Is that's another type?
Beehives, yeah.
Yeah. And are those also a thing where it's like this vent field is known for beehives?
Yeah, I would say beehives are much more common though.
Okay.
Yeah, whereas the flange thing seems to be, just a handful.
Yeah.
Temporal thing where it's just a stage of the development or something?
Maybe. Depth, I've never actually checked to see if they all occur at a common. There's something about that depth.
Pescadero is one of the ones that's doing that, right?
Yes.
Currents? If you had a strong current moving through, would that influence how a chimney formed?
I'm sure it must somehow. I'm not. I don't know. But it's again, it's not like we only see them on one side of a chimney, right?
That'd be cool, though.
These are all good ideas. All testable hypotheses.
All papers are right.
You guys just wrote my next grant application.
Flange quest.
We'll become our own flangologists.
Did they ever get that house that they left this year? Mari was supposed to go pick it up. They made a metal house and put it on one of the flanges that had like a little breakthrough.
Like they put it down on
So
one of them?
like it was venting up through it, and you put a chimney on it to see how it would actually grow on.
Of course they did. Those Mbari guys. What
Well,
did they do?
we made it.
Oh,
to
you
put
guys
down
made it.
for the scientists, and then the scientist was coming back there with it Bari, and they were.
Oh, I see.
You never heard about them? What? It just disintegrated to death. They couldn't find it, and overbroke it.
So typically, what's the last chemical or mineral that you'll be finding in fluid? Like you said, like you'll see some that are very wispy smoke. Like what's the last thing that really stays in there?
Probably the last, in the lowest temperature, which would be the last. Usually it's silica and iron and manganese, sorry. Those are usually the if you sort of start with your highest temperature, then as the fluid cools, you start with things like chalcopyrite and pyrrhotite, so sulfide minerals with copper and iron. And then you get your sphalerites and your galenas, which are zinc and lead sulfide minerals, and you work your way down. You get pyrite and marcasite and hydrite and barite. And anyway, the last one's on the list. And if you find sort of dead chimneys, often the inner conduit, you could see this gradation, this temperature gradation, and it's usually a combination of silica and then the iron and manganese are at a very low temperature. Most of that just goes off into the seawater or accumulates around. But those are generally the last to make it.
Has anyone attempted to map in very high resolution, very active hydrothermal vents? Seems like a sound velocity, sound speed nightmare. But
LiDAR and photogrammetry, yeah.
Yeah, those are generally.
But acoustically, could you do it?
If it's an active vent where all of the activity is being forced out the top,
yeah,
which is rare. Usually there's stuff coming out everywhere. So yeah, it sounds like a light-based method is better for
not
that.
acoustic.
Yeah. We're really interested on this expedition to see how the not only the multibeam but the SAS interact with a plume and smoke. Yeah. And that'll be a really interesting experiment.
What's your favorite website that you've been to outside of this?
For folks just joining us, you're curious what's going on. We're kind of having like a little radio hour here. We are currently 2,412 meters below the surface with the remotely operated vehicle SuBastian. but we're not at the bottom. We are just shy of 45 meters off of the bottom and mapping as we go. So this will be the first portion of this dive, is mapping using the M3 multibeam sonar mounted on the back of ROV SuBastian. And so what you see on the right side there is data from that multibeam unit. So that does require that we're kind of just up in the water column. It's a good time to talk about the region, about the science, and you're joining us kind of at a fun time there where we were having a discussion about the vents. But later this dive, we will be touching down, getting down close to the deck, and looking at the rose garden vent area.
Great, thanks for doing that.
All right, my favorite vent field. Will you allow me my top two? Top two, first one is Niua South, which is near Tonga, which we actually investigated on the old Falcor.
Yeah, I did. I was on there with Ken Rubin on the underwater fire.
Right, so that was the cruise after ours. Ours was Tom Kwasniczka at Geomar was the chief scientist, and it's called Virtual Vents. The reason that vent field was so neat is because the chimneys are all spectacular, tall and black smoke and beehives and lots of animals, but it was all contained within a essentially 500 meter diameter crater. And so just very neatly packaged, circular bottom, just all these vents. It was really cool. And then 2019 went with the group of ROV Ocean and University of Bergen and Tromsø on the Norwegian icebreaker Crown Prince Haakon to the Aurora vent field, which is the most northerly. We're actually the first to ever explore with an ROV a vent field under permanent ice. So we went up with an icebreaker that had a moon pool, and we launched the ROV through the bottom of the ship, and we had to drift with the ice and time it with the descent to get to the seafloor. It was spectacular. It was the first time I've ever worked up near the pole. We were at 83 degrees north, and the vent field was spectacular, but just the whole process of getting there on an icebreaker and being able to explore and it was pioneering work. People had tried before to do this, and so that really has a special.
Did you have much time?
Oh, I think the most bottom time we had may have been 3 hours or so because of the drift. The ship would just drift on by, and there's not a thing you could do about it. So you had to, predict the ice movement and direction, and then position the ship up ice, which is not hard to do or not easy to do, and then launch so you get to the bottom in time and try to get ahead of the ship as much as you can. Do your work while the ship drifts overhead, and then sooner or later starts yanking on you, and then that was the end of the dive. You had to bring it back up and then move the ship and fight back through the ice to get up ice again, and try. It was incredible. But we did it. The guys who pulled that off, it was amazing.
You're the first person I would met that's been out with ROV.
That's been out with ROV Ocean. Yeah, those guys are great. A really good ROV and a really great team, and I'm really excited for them to get their vessel up and running. They got one of those submersibles with the domes. Chong, what are those called? The Triton? Triton. Oh man.
They bought the first 2,000 meter one.
Can't imagine going in a 2,000 meter submersible with a acrylic dome over your head. Yeah. Gives me the heebie-jeebies thinking about it.
Any of our old mentees with that old lead and T?
Oh yeah, Leighton was out with us on that. Yeah. Yeah, I think he's their chief pilot now for that submersible.
What was that? SOI for 2 years. I still was waiting when she was at law.
Right.
And then she headhunted SOI.
Yeah.
That was not right.
It's a small world. We all got to be nice to each other.
There's a question in the chat about how does InSAS work? Are we prepared to answer that?
Caroline just went to bed. I could try to explain it, but it would be best to save that question because she is the expert.
Okay.
But if people are wondering now, I'm going to butcher this, but I can at least give you the basics of SAS. Normally, it's a fancy type of side scan sonar. So side scan sonar is taking a photograph of the seafloor with sound. It's an acoustic image using sound ping. So it's kind of like multibeam, what we're doing now, but you're shooting them off sideways and then building a picture based on the intensity, the volume of the return signal. So that's traditional side scan sonar. And with side scan sonar, if you have a vehicle, it's moving along and it pings out, and then it bounces back, and there's your data point from that one ping for that one footprint on the seafloor. And as a ping shoots out from a vehicle, the sound wave is essentially it broadens with distance. It gets wider. It's like a cone going out. And so the further away you are from your source, the bigger the footprint and the lower the resolution. So if you're near the vehicle, you could get fine detail from the seafloor, but as you go further away, your sound wave gets bigger, and so you can only see bigger things, lower resolution. What the synthetic aperture sonar does is it for any one spot on the seafloor, you'll actually hit it multiple times with multiple pings. And which you'd get with regular side scan sonar, but it's how you crunch the data, that you first hit the edge of the ping with your or the edge of the object with your first ping, and then your vehicle moves, and then your next ping will hit it again, and that keeps happening until your last ping that hits that object, and then the vehicle is gone. And by processing those data, and that's as much detail as I can give you with respect to that, magic happens with math and stuff in a computer. It takes all of that and can reconstruct points based on more than just that single ping, but multiple pings that have spread out and hit it from different as your vehicle has moved along. And that's sort of the synthetic part of this process. So I don't know if that made sense to anybody, because I certainly didn't understand anything I just said. But that's the difference between regular side scan and synthetic aperture sonar. And this process allows you to get not only much higher resolution, but the resolution is no longer range dependent. So again, the side scan, further away, lower resolution, fuzzier, because things that are further away with the synthetic aperture sonar, you're actually hitting it with more pings. So that's the trade-off that allows you to maintain that resolution.
So, like, our blue view is the same thing, but the head has the same size head and receiver, but with InSAS, the transmitter is small and you have the bigger receiver, so
That's correct.
that further ping that's coming back, it can process that wider thing and be able to do the math, as you say, and know how far away it was, and then also rebuild it, which is how far it is.
That sounds correct to me, yes.
And that because your survey altitude is based mostly on shading from
Yes.
structures.
And that's where one of the challenges on this expedition is because the synthetic aperture sonar has been mostly used so far and developed for defense purposes and sort of offshore oil and gas and pipelines, that sort of thing. And that most of that activity is shallow continental shelf, flat sedimented areas. And we are exploring right now an underwater mountain range. There are peaks and valleys and cliffs, and it's a mess. And so one of the things we're really trying to evaluate on this project is how can you apply synthetic aperture sonar in an environment like this? What are the limitations? How do we design our surveys so we could optimize the data that we get? This has never really been tried in terrain like this to this extent, so it will be interesting.
You just chill, just around.
We're happy to have you here.
Thank you. Nice being here.
There's all this talk of gummy bears. What?
I'm waiting for things to go a little bit smoother before I bring out my number.
I see. Okay. I apologize for jumping the gun on the gummy bears. Right.
That's valid.
Just a few more hours, and then we'll hit the button.
Okay, so there's no option that they'll cancel the dive and we'll use somewhere else. Like here.
No, we're happy. Are you happy here?
I'm always here.
Something you want to say? Okay, I'll keep everyone updated on what's happening. 5 is sort of my loose prediction. Yeah.
Standard line, started for 6.
Gracias.
I can see you working on that.
You want a logging break?
Practically fluid.
They switch out at 4 o'clock. One of those guys. Interested.
So, finish this and then going to the right inputs, or is there any other?
Yeah, no, we'll just we'll work our way up towards that waypoint, but we want to test out photogrammetry survey along the seafloor as we do have from those ponds. Maybe go through this sort of modification. But anyway, and then it's a free for all.
And I think I just have to prove it. Also, get my computers of the weather to be able to help with that. So we can use that. After that, the process of make sure for the
Also see which paper. Oh, great. Okay.
That's pin the line starting 47.
47. Yeah. And you're down one person. Yeah. Right. So. Yes. Let me start with the first thing is 46. Is this cause for moving someone so that another ship is short? Someone's gonna have to be short. Is there a more appropriate ship for that short? It kind of makes sense that you guys are short. It makes sense. Because there's fewer people missing. Doesn't help you guys, but it helps it move. And we make decisions based on it. Yeah, that's not. So that's what we need to do. Everything is treat people in out of the ships. Like it's not like we're doing 12 and 12 or changing the ship. We are complete reset of your life.
Like we told Charles, like
just in a couple of weeks, he wants to switch to the USC. I think that would be a fair thing.
So and then for now, you know, I'm sure just not so much of like
No,
So we are still working our way through our series of lines. We are slowly heading south. We have a few more lines to go, and then we will be dipping down to do some photogrammetry, to take a look at the vent field, or what's left of the vent field. There's a question in the chat asking if we will be docking in Galapagos, and the answer is we will be coming in for a quick transfer. In the Galapagos, we take on board observers that observe our work and make sure we're following protocol, and are also just a good resource to have that are familiar on the Galapagos area. And so we will be stopping in Puerto Ayora to pick them up, and then we will also be going back before leaving Galapagos to drop them off. So we, on the last expedition, had a few days of port call to see a little bit of Galapagos, and I can say for certain that you definitely need a lot more time than we had there to really get a good picture of what Galapagos has to offer. It's a really magical place.
I can see it becoming a problem when you're on shift for everyone else and doing their samples since they have to. But then if people are being trees and we can always just come in here.
Which reminds me, I've been doing some stuff that I wanted to show you because I have an idea for the latter part of this dive.
Oh yeah.
Yeah. So I watched videos and there's 2 actual biological hotspots. They're 9 centimeters so not from each other, just in this area, live plants. Yeah. So I just showed Verena and she confirmed. And the geological feature is very large and the biological signal was significant. Like we shouldn't miss it. It's a big cleft and it has secure rooms all over it and we're kind of at the bottom. So my first question is where...
Okay, so in the top left map, you can see the ship, which is blue, and then the ROV is just a little yellow, kind of in the top center there. We are zigzagging our way to the south towards the bottom. As he scrolled off, we worked our way from the southwest of the square to the north, hopped over, and then we're now working our way south. So we have 1, 2, 3, 4, 5, about 6 more lines to go, and then we will head to the bottom and do a transect to about where we are now, just at the bottom, and see what we find.
We're back here again. And then multiple Pacific Whitescape. So there was no
we did have some time in Galapagos to go ashore, and there is quite an abundance of life, and they are all not bothered by humans to a surprising amount. You'll see sea lions sleeping on park benches. Oftentimes they'll just decide to take a snooze in the road and people will cone them off so that they're safe from cars. There's giant tortoises roaming around in the more rural areas. There's finches all over. Marine iguanas you can see swimming. We also saw a bunch of hammerheads. I thought you would have to kind of go searching to see animals, but they are all over the place, and yeah, they're definitely adapting to human existence by sleeping on park benches and interacting with fishermen and stuff.
Yeah. Yeah. You just ordered that.
But
so when they
keep out of here.
So this is a spot where I think we should go based on the 2015. Here it was completely paved and nothing notable, like not even knowing where we were. It was this huge hour gap where there was just nothing, and that's when it was over these 2 points. So the best target is this.
If it's true.
So, okay, let's see if we can get points on the screen. This is easiest to do that way, and not go that long.
Okay, great.
And, yeah, okay.
Paying attention to that really makes a difference.
To what?
Good, Doug. Thank you.
Yeah, okay. Let's finish this off. Okay? Yeah. The key thing is don't feel like you are glued to be here. There's absolutely no reason anyone should be screwed. So. Then no thanks. Then it's stop because we're all here. But I'll mention this during a science meeting.
You really don't like us.
It'll depend on what's happening here and whether or not. I'll just write a message to everybody.
Sorry for you.
Where's better to be on the ship than this? Is there anywhere better to be on the ship? Look how many TVs we could.
Thanks, Sheila.
Alright, so
Okay, we just did a watch change here. Thank you to everyone tuning in. We are currently mapping an area in the hydrothermal vent field off of Galapagos Islands. We are currently diving with ROV SuBastian with Schmidt Ocean Institute. And the displays you're seeing here, the upper left is our main Science 4K camera. All of the writing on the bottom left are real-time feeds that we're currently getting from our ROV, which includes heading and oxygen, as well as CTD data, conductivity, temperature, and depth, as well as altitude from the bottom. So we're currently 45 meters off of the seafloor. And the reason we're 45 meters up is because we have a M3 sonar, which is a multibeam sonar that we are currently mapping below us. So there in the top right corner of your display, you're seeing a real-time live output of the multibeam sonar. Multibeams work by sending out several hundred beams in a horizontal pattern to our current direction. So if you're looking at the top right, you just saw a fan pattern. That's because our ROV just turned onto our line, and then they are going to continue making a straight transect to cover or color the seafloor. So all of the fan patterns are made up of hundreds of individual beams. That sound that gets sent out from our sonar, it will reflect on whatever object it finds on the bottom of the seafloor, and return back to the sonar. So the sonar will send out pings, wait for it to return, and based on the amount of time it takes, it's either traveled farther, aka found a deep part, or it gets back to the sonar faster, or it found a shallow part. So by putting together all of those hundreds of beams, it will create a swath of the bathymetry or seafloor typography below the ROV. So this type of mapping gives us very high resolution. It will be sub-meter resolution, which allows us to really paint a highly accurate, high-resolution photo 3D rendering of the seafloor here. So it takes us several hours to run these lines. We have to maintain a certain speed and height and heading in order to get good data. And so you're watching in the top right corner, that's what we call the waterfall view. You'll see as we head to the west, you'll start seeing more and more of color building to the west. And so as we build that feed, that's the real-time seafloor typography that's underneath the ROV. The bottom right feed is a water column view of the sonar. So you'll see a really bright gold color. That's actually bottom detection there. The gold is the highest returns received by the sonar. And so you can see a little hump in the center there that's a little bit higher than around it. That's just because we went over a rock, and so it's picking up the seabed. So if you look closely, you'll see that gold line will kind of paint the same swath picture as the line above it. Oh, we're happy to have you guys tuning in with us. This is actually a special site. This is the site where hydrothermal vents were discovered in the late 70s. So between 2002 and 2012, there was a eruption that most likely wiped out a lot of the hydrothermal vents in this area. And so after we are done mapping this line, these lines, I think we have, let's see, about 4.5 left to go. We will be dropping down and taking a look at the seafloor and seeing what's left here and what sort of activities we may see. vent field that we're diving on, that you'll see shortly here, is called Rose Garden. It was named by a group of geologists who believed that they would find some sort of hydrothermal activity based on temperature and other measurements taken of this area. And they came back with the AUV, or the submersible Alvin. And when they arrived to this area, they found an abundance of life on these hydrothermal vents. So they did locate venting, but one thing that they were surprised to see was a whole ecosystem here. So this ecosystem, they were surprised because we mentioned, we were talking about this earlier, but up until then, all life was assumed to stem from light, and no one believed that there would be communities this deep. We're currently about 2,500 meters, just shy of that, and they were really surprised to see tube worms and what we call riftia in this area. And so riftia has kind of white tubes as well as a red top, and so they called it the whole vent field. They named Rose Garden because they thought it looked like roses. And so in 2002, they came back, and a lot of the hydrothermal venting had died down due to lava flows and previous eruptions. And so they found one diffuse vent site that they named Rosebud, just as a symbolic piece to the rose garden. Okay, I'm going to hand it back over to Alex. Feel free to keep asking questions, and we're going to keep mapping for a little bit more, and then hopefully drop down and see what this place has to offer.
Could have chilled.
I know.
So I was told
Thank you.
In the line?
Your life?
Alright, let's take them down next.
Well, thank you to Juliana for jumping in. Let me hop out and grab a glass of water real quick. If you're just joining us, maybe you've never tuned in for one of these dives before, this is live footage from a remotely operated vehicle currently working 2,414 meters below the surface of the ocean. Vehicle's named SuBastian. It's being controlled from onboard research vessel Falkor 2, operated by Schmidt Ocean Institute. And this is actually our first dive of our current expedition, our new expedition, conducting ultra fine scale seafloor mapping near the Galapagos spreading center. So although we are quite deep, we're still not all the way at the bottom. We are 45 meters up off the bottom, and that is because we're currently conducting some mapping. So on your screen, over on the right side, you can see some of the feed out from that mapping. On the bottom, we have actually like the little arc there. But up above, we have the waterfall. And so that basically, down below, you can see there's an area that's brighter, a brighter yellow line. That's basically where the ground is. And you can see it's a little wobbly. And as we move, those wobbles actually change. And that's because it's hitting the variations in the terrain below ROV SuBastian. And so each of those little lines up above that you can see, when we turn especially, you can see it's actually made up of multiple lines. Each one of those captures those variations, and when you stack them all up on each other, like we do in this waterfall, then you get a representation of the terrain. So the first half of this dive is this mapping, is some surveying using the M3 multibeam sonar on board. We actually have that mounted on the back of ROV SuBastian. So if I kick on over into our rear camera, you can actually make out the umbilical up towards the top there. But over in the lower right, there's a mount there, and that's where the M3 multibeam is mounted to, facing downward. So as we are traveling along, it's sending out waves of sound downwards. Those bounce off the ground 45 meters below us. And when they are received back, based on how much time it's taking to get back up, we can tell how far away the item it bounced off was, and we can put together a map. After we map this area, we've got a few more hours yet, we're going to drop on down and actually explore the area more closely. If you're interested in learning more about this particular expedition, I have posted in the chat and pinned it to the top a link that'll take you to the cruise page for this particular cruise. That's over at schmidtocean.org. While you're there, you can back on out to the main cruises page and see the cruises from earlier in the year, as well as our next and final cruise for the year, which is Lake 2 of our Octopus Odyssey expedition.
ROVs? No. It's a lot better. It's actually, they're always a piece of speed.
Yeah, we don't have roll or pitch controls, really. There are ROVs that can tip themselves over and stuff. Either of you ever worked on an ROV that could do a backflip, hypothetically?
Not that I ever thought about trying.
No? I've messed with a Blue Robotics ROV too, and you can tip it like 50 degrees and lock it for hull inspections, but if you just keep going with it, it'll flip. It's not controlled, but it'll flip over.
Maybe I can control every thruster we had independently, so I probably could get a pretty decent.
You think we could get one on, yeah?
No, we cannot. Look it, but we go out and heavy fight.
Yeah.
I can get a decent roll.
Yeah.
If I tried, I'm sure Jason.
That's true. You do have independent control, so if you cranked the verts in opposite direction, it gives us a little bit of a roll, but not enough.
No. I know now.
Have you ever really used that ability?
We used it, well, not necessarily opposite. We had an issue with it howling on a vert thruster one dive, and we were concerned that vibration of using it would force it to fly away. So we had to secure it. Well, then we went through the individual, so vert thrust with just the port.
Okay.
Then I was talking about
Yeah. So you've used the verts independently when you haven't wanted to use one of them.
Exactly. Yeah.
Okay.
Not to go the opposite direction of the other one, but just to isolate what we were worried about.
And I suppose that's why they're able to be independently controlled, is to be a little more flexible.
Yeah. If we needed to, for whatever reason, we needed to adjust our pitch or our roll, but the main issue we get out of it would just be tide placing issues.
Yeah. Now, in the model of the Blue Robotics is like their heavy model, and it has 8 thrusters. It's got 4 verticals, 1 in each corner, and that lets you kind of force it into an angle so that you can look up better, but not really intended for maneuverable flight.
There's some of that habit issue. Isolate the cluster. It's easy to, if you have a heavy payload in the front.
Just tip it. Yeah.
So you're not fine with that. If you don't have that payload, use it, kind of point up its side a little bit. But I don't think it's strong enough to do an action.
Yeah. Yeah.
Again, never tried it.
No, I think a lot of the stability of ROV SuBastian is primarily through the orientation of the floats and the weight. If you've got the floats up top and the weights shifted down below, like if we slapped the floats on the very bottom, then it's going to be not stable.
That's why they don't make life jackets in the form of socks.
I mean, it's one of the things you learn when you're getting like dry suit certed is what to do when all the air gets into your legs. Because you got to be able to flip yourself back upright. So, buoyancy is a tricky game sometimes.
Good question. It started last cruise, so we were thinking it was probably 5 or 2 out of our camera model. We looked into that. So, there's an issue. If it was an issue, there's definitely another issue. If I had to speculate, it's that we have a common issue, probably the fiber somewhere, so the fiber in front of the edge of the site. Alright, that's end of line. So then, on the next one. So, whoever conditions are affecting yeah. Camera, junction box, and locally mounted. Alright, ready for the next line? 053, start the line.
053. Those lines,
I don't really mess with them anymore, but I like the fan.
You did used to like the claw machines? Yeah. Yeah. I'm more of the quarter pusher, little coin pusher thing.
Those aren't as
Like, I like the claw machine, but I don't know, the coin pushers. You good at the claw machine, Claude? Yeah, like the little stuffed animals in a box, and it's got the little claw. No, that's not you. Oh, Operation? Yeah. But we should make you play Operation with using the manips. Almost. might get a sunset. We'll see. See what happens.
Seems like that happens every day, though.
Yeah. Sometimes. Sometimes it rises.
Yes. What's that? Blood markers. So we gotta put on an angle. That's not good. No. Markers. That's end of line.
Line?
Oh yeah, iPad.
Any holes in the data, Craig?
No, we got really good overlap. In the future, we might be able to even spread the manifold a little more. Go to the ground faster.
Great.
For May, 50 meters next. We like 50 meters. It's good. It's good data density. We're getting both sides of all the features.
Yeah.
It's nice. Yeah, it's nice and slow.
Yeah.
Alright, third line 055.
When we get down to the seafloor, should we release now?
So we've got various things that we're looking to try and collect biologically. Now, we are worried that we might get down there and not find a whole lot as far as diversity goes. The vent is very likely inactive, or perhaps only venting low temperature fluid, but we are going to keep an eye out, collect any opportunistic samples that we might of riftia or clams, mussels. When we were cruising around earlier, we did see a decent amount of sea cucumbers when we touched down. Some anemones. We're also going to keep our eyes peeled for skate eggs. Potentially collect a few of those if we find them. And where there's skate eggs, perhaps there are adult skates, so we're going to keep an eye out for them as well. We do have folks on board interested in corals and sponges, so eyes peeled on those. Yeah.
On C-Log, the case map is, in my view, toggled off.
So if it says it down at the bottom, that just means that it's hiding it from your view when you're searching. Because otherwise, if that's toggled on, you just have like thousands of A-snaps in the search.
Yeah.
They're still being recorded.
I don't want thousands.
No. You're just talking down here at the bottom, next to like frame grab.
Yeah.
Yep, that's just hiding them. if you're concerned about it, if you scroll all the way down to the bottom, on the left at the very bottom, you can see the status of ASNAP is on. As well as the free space, just in case. You never know. No, we've still got a little while left of the mapping. We're getting there. But they were doing some stuff on the mapping computer, although they look to be done with that now. So I can toss our little display back up.
Although it could be that there's inflation.
I don't know if this is real or not. Some kind of frontal side. I'm sure.
Drain back up. So the lava comes up, you got a fault here. Lava comes up the fault, fills the way, and then drains back. In fact, all of the last time you see hit the drain, somewhere
No, these aren't real. These are just. The idea is something actually no regulations of this. It's reading the knowledge. It's all on the internet. It's the way it's there's no other. They have to look at their
what's back down
here. I'm not sure. It's 48 to 39. Below the stance of the we have to start calling the top as possible. There's no street that's an elevation. We move on to the area is a lot rougher. So in terms of efficient use of the ROV, that's the pretty features application. This is a higher house calibration, so it might just be the downside of the survey. Yes.
Was I correct in saying that we could accommodate area into
Define large.
I believe the bigger the better. Bigger. Like he wants it to bigger the stem, but towards the tip. But it is a big percent. He's very good with protocol. The trouble is the base that has the history. Yeah. You can't just snap off and fall and leave it on. It's a very big world.
I mean, we can only collect for him what we can store on the ROV.
Exactly.
Well,
exactly.
it's not going to be. They aren't going to be the juggle.
Okay.
They're going to be things like this. I think. Right. Based on what we've been seeing in the imagery.
Right.
And
So quarter bio box. I mean, that's as big as we
I
have.
know.
We,
I guess we'll say that probably. I don't know what to say.
I just don't see a sea for big corals at 2.5 kilometers down on a new laboratory.
We haven't seen it.
so we've got one open bio box.
Right.
Now, can we put multiple corals? As long as we could keep
Well,
track of
it's
them.
kind of like the rocks.
Sometimes in this class,
Yeah.
Find what they
no,
are.
sometimes in this class,
Right.
And I'm not worried about it on the stuff. You're not going to see.
compression.
You're not going to see it.
Compression.
Well, it's not glass.
This one freezes, this one won't. So you get
Oh.
Maybe after this guy.
sometimes that's what it is, sometimes they're actually,
With Evan, good luck. With
the violation is full like that and it collapsed.
oh wait, it's only 5. Yeah. Yeah. Okay. I thought it was later.
Or tomorrow. Or whenever.
The associate's important, or it's just
So what was your original question?
The original question was I correct in saying that we probably can't accommodate sampling a lot? Which I believe if it's only one biobox, I would say that's correct.
Yes. Does he have an expectation for numbers?
That's a good point. I've collected for Evan on some expeditions before, and like we've sampled corals and like tucked them under the arm and then like flown up, but like got the base, but like it wasn't like it needs to go into this firebox and like and he still used it all. I'm not saying we treat the corals roughly, but like we weren't like separating them. They were obviously different. We did our due diligence, but
end of line.
he was very happy, and we just got him, I think, like 6 on the entire expedition, and he took them and was super happy.
Oh, great. Okay, so it's not like 10 per dive or something.
No.
Okay. No. He also takes segments, which is great.
Right.
So if there's like a dozen.
Is that what he calls fossilized corals? Because he has this sort of weird terminology.
Yeah.
Which is 10 meters back.
My experience with fossils is
They're really brittle.
they were. They wouldn't always get to say brittle. They all the last thing that it was just rough all over the sea.
Yeah.
Some of them were like still the matrix still and whatever, not really just a little easier like this.
That's probably
New England.
2000 one died, one swung us, and we just grabbed like 6, one was dead, and like he took it. So I was like, thank you so much. So, yeah, sorry I didn't realize you were grappling with like 10s on a dive. We just wanted to be able to manage it because we had super happy.
Okay. Yeah, I didn't know those expectations were all.
Big problem with those collection sheets.
Alright, let's start line 057.
Last line.
Third line.
shown it to John.
Yeah, yes, yeah. Oh, sure.
So there are a couple things.
Why don't you run first, and then when we start getting closer, we'll just do a little strip of that. Because how it works, and then if what really buggers it out, at least I have a little section to test with that. But they get, you turn them off and 20 minutes back on. But I just want to play with some real data. Because you heard about what I did. I did X40 on the ones that had lasers and the ones that had timestamps. And so it attached those points like they were real, and it worked space-time continuum by making a flare. It's horrendous. And it's like, oh no, I was like, do I save this project? And I was like, nope. Would this be useful for you in the future? No. Multiverse. That's what I created. These are it's awesome.
This one is a vertical generation. Only 2 times the earth. Less than mine.
Something like something that doesn't get
Oh yeah, that's like a bump.
Yeah, still 10 meters high.
Yeah, that's right. I mean, we're making our way over that direction anyway.
Push up ridges. Okay, so is there anything else? It'd be worthwhile finding out what that is.
This night here?
Yeah, since we're in a lot of it's coming. I expect it's to go on.
Is that shit things?
No, it's the stuff I'm putting out.
Oh, wow.
Well, what we can do right now is figure out which are the waveforms, what's the corresponds, and what's the survey lines. Yeah. So you know which survey line that's on the waveform. You have the lines on that. Oh yeah, I can turn it back on. So that puts 2D. So it's north, just north of the top line. With the blue view, we can be able to see that. So it's about 50 meters north of that top line. And how far from the first marker to the west? 100 meters. So 100 meters in, 50 up. Okay.
Can you zoom out again?
Sure.
And north, so north is north?
North is north.
Okay. So what other features are potential targets? Oh, well, the fault that I think that should be ground truth.
This one here?
So we should look at that to ground truth. I mean, that's what you're doing, right? Is going down to ground truth the features.
Absolutely. Yeah.
Otherwise, you can't use that information elsewhere.
Given what it is.
Yeah.
How wide is it?
Okay. It's a 10 meters wide. 10 meters from the top. And what's that?
Is this it coming up here?
Again? Yeah.
Not to do the are we there yet?
Excruciating pain of staring at sea water
No,
is
it's all just,
almost over.
It's just space truck event. It's just cruising through the void.
Yeah, this
Is this it? Just
It would be good to confirm that it is a wrong stuff. I mean, that's the whole idea, right? You go down and you retrace your steps, so anytime you see something like that. Well, last time we saw that around the 100 or green. Yeah, so there's 3 things right there, 4 things right there.
Smaller species we see rarely.
Most of the human items that we find, anthropogenic items, that's it. So most of the items we find are just debris that's fallen over or was thrown over, right? We do find a soda can now and then. Usually someone does a little bit of Coke can archaeology and looks up what years had what design. And we found some older cans. We'll also occasionally find lost fishing gear, and that can actually be a hazard. So we would stay away from that if we found like a net, like a ghost net or fishing line, anything like that. We stay clear of that, because if that gets into the thrusters on the ROV, then that's no good. So that sort of stuff we stay clear of. Larger items of note, you know, if we're in someone's water, we would want to inform them that, like, hey, there's a shipwreck here, something like that. And there have been shipwrecks found during mapping cruises and ROV dives and that sort of thing. Not one that I can think of recently, but it happens. Yeah, the last dive of last expedition, we found some, like, fishing weights. They might have been net weights or something like that. We recovered quite a few of those, but then there were a couple. Actually, Chris was grabbing those. But there were a couple that had fishing line, and so, like, those ones we're not going to touch, because if that line gets into a prop, then we're out of luck. And more frequently dove sites. Like, I remember it might have been Endeavour Ventfield had, like, notes that pilots have going in that are like, hey, previous dives have found, you know, fishing line over here, XYZ over here, because it's an obstacle that you need to be aware of. Do not mess around with anything that could get into the thrusters.
And the line.
End of the line.
Let's go down to the seafloor.
All right.
Then from there. Well, you just numbered these 1 to 14.
Yeah.
Yeah. Right where we left it. So the idea here is if we can zoom out on your nav screen to the north, almost green over there, yeah. Essentially going to head in that direction. Do you have a visual distance easily? Or just give me an estimate?
So, 452 meters.
Okay, that's good.
So, yeah, we go to far away.
That's like 680, 690.
No, it is sometimes stronger. So do we
But we could do the photo mosaic transect.
Yeah.
We don't need to do a 600 kilometer meter.
Do we suspect that this that we're going to get into is active?
We suspect nothing.
This was the most active here.
Okay. Why don't we just go to within 300 meters and then drop down to 7
The alternative to that is we go there and it's slightly active. We're going to have to transit back to the west. We know your zero starting point. It's up to you.
I'm saying that makes more sense because I think we know it counts on that. And then that also gives us the good feel to do for watching. We don't know where we're going. We don't know what's around. So if the camera's up, we're going to ask for it to be facing directly down. We're going to fly straight to the ground.
Ready, Darwin, it's the waypoint for you.
That's a good idea. You just fly there on water to get there, and we'll do the practice transit from there. It gives us the ability to research.
So, right, we're going to head to the.
It wouldn't be your fault that you directly.
We're not going to do the foreground because it's just flying.
Do that in a few minutes. I'll look around here, and
Existing data already, and it's in my mind of the lasers. Hold on. No. Still.
No, they're not. I don't believe.
You want them on.
Like that? Is that what you want? Oh.
So 10 centimeters.
Yeah, I guess that's all it is. Yeah.
Yeah, it's the furthest northeast. That's the one.
Still gotta look at the ship to be fast, but
This is blue, is it?
No, that's
Are you gonna get the ship in front of you, or?
yeah.
why they're exposed.
Ideally, I should guess the side of the vessel.
All of this, even where they're flat, can actually be hollow and sandy. And so this is where the seafloor has broken and just exposed the tubes. Oh, yeah. Yeah. So we're doing the pool survey right now. Yeah.
So this is the takeoff chute. Basket now.
There's a lot of times.
Don't collect the coals.
RVs landing so they can solid.
That's yours.
Are we going to be needing a snap to be in one?
Not yet. When we do the photogrammetry, well, then it'll be 1 second.
That's not now, though.
That's not now.
The lasers are on.
Lasers are on. You can see them right
Oh, yeah.
there.
So you're not responding to the chat, right?
I'm not even going near that. It's nice to see it because then you know that Alex is on.
Yeah.
But yeah. But suddenly the blue view is useful again.
Yes.
Yeah, I can put, if you need other stuff over there, I can put other stuff over there. So let me know. Outside of the pilots wanting sonars.
And then this is the dive plan, which is
So
Yeah, but it's move. You guys can go for a fight.
we're going to go there, going back,
yeah.
and then now there's two bottom features that Mark was talking about. Is that the next dive or is that this dive? The next dive's coming right to the same spot.
We're not sure yet. So it would be part of this dive.
Okay, well,
Maybe the goal should be to end at that pinnacle he found.
right.
Unless it's super cool, we keep going.
Okay, which means we will need a,
No, we want to move up closer than that. Yeah, we need to be.
or is it low enough in the grid that'll work?
We'll figure it out because
You'll figure it out when
show you
Have him parallel our.
on the map.
You want to go this way?
Yeah.
So disorganized. What we do know is this top line 100 meters from that waypoint and 50 meters north of it is where it is. So just sort of right in there. So I think with the blue view you'll be able to see it when we sort of get to that area.
Tomer has put the sprint data in.
Okay.
Quickly putting up full surface now. He's just finishing it up and he'll put it into flight. So we have real depth.
Okay.
So good. We still got a lot of them. It's all really pretty bad.
Yeah. Good. Great.
Crazy hole.
The headphones are here, Marina, if you want to listen to what Alex is saying. Blah, blah, blah.
I'll move over and just fly further to the west so we can get this started. Yeah, that's fine. Yeah.
That was the original plan. Now we're just
I think that's my song.
I just did works in work stuff, which was nice. Yeah.
A few weeks ago. Yeah. He was fine. But I find like podcasts, especially when they do that hour-long one, where it's like, I'm bored and I'm the one that's bored. Bob's was really fun. 20 minutes. And I like it. It was like, you decide to guess where to show. And I was like, that was much. Me, that was fun. No. He would have, well, he was on the previous stuff that makes. Yeah. So they've done it different times. Yeah. That was actually on Zoom, but then I met with it just happened to be in Victoria for shows through that afterwards. But they yeah, they had some dates before we were before. Obviously Zoom changed a lot. Instead of it, it's boring. Essentially, it's like Zoom. It's locally recorded on your computer. So even when they read in person, they still use the submarine technology of local recording of different players. I feel like it will burn a lot of things. It is not like the best technology service. It's supposed to be done. It's not early. So it's responsible. And the YouTube radio stuff, I just was so much fun. And it seems so much everyone's technology for remote communication. So now the most cutting edge stuff is actually attached to the remote.
Those look like sponges. Monica?
Yes.
See a little. What have we got in the bottom here?
On the left is this fish. In the middle, you mean?
No, the little whites. The white.
Oh, I think that's
The xenophyophores.
See, they're everywhere.
Yeah, they're everywhere.
Shut up.
Oh, that's so cool.
And what is this?
Holy moly.
That's right, the orphan was talking about.
Okay, so yeah, we're looking at a benthic hydrosome. We're looking at a little sea urchin, but these white knobby things are calcareous. That's about, well, 10 centimeters across. You can see the lasers. And they are, it really is, right? Those aren't glass sponges. No, they aren't. No, they are, yeah. So they are colonial, well, they're protozoans.
They're protists.
Protists, yeah. And take it away. Tell us more.
Xenophyophores are giant protists, and they have they're a single cell organism. Their actual body is a tube network-like thing that is actually just bound by one single membrane. And they have thousands, tens of thousands of nuclei inside this one single cell. And it's divided into two parts. One part is, which takes up most of the body, is actually what we think is their site of defecation. So those are black, and they are not alive. And there's only a small part of this living cell is actually alive. And those are the parts that actively feed and grow. But we don't actually know how they grow and how they feed, which is a fascinating fact about the xenophyophores.
That's awesome.
Yeah,
I actually have no idea. And we know they grow in two cases that we have been able to document their growth. They actually grow in phases, so they don't grow for a long time, and then they suddenly grow an entire chamber, like part of their body, within a very short period of time. And the coolest thing is, the individuals that live close together seem to grow at the same time, but we don't know how they coordinate that. Yeah. So
be seen twice in this issue.
Have you ever seen one in the wild before?
It's sort of just an engineering marvel, actually, even though it looks a little grotty. A lot of detritus on top, so all of this is pelagic sediments. Oh, cool. Alrighty, we can truck on. That was unexpected. I'm just wondering if this isn't an older. Be interesting whether this is an older lava.
There's young lava on top of older lava.
But this spot.
The sediment cover on the flat sheet flows can be deceptive. It doesn't take very much.
No, I know. It's just that they seem to have established in this little pit.
Yeah.
People think suicide forests take a long time to grow, but they will actually take months.
It'll come up, but it's not gonna make
So it could well be. They could well have colonized.
Yes.
Okay.
But yeah, no, this is all just lava. It cools, and there's gases underneath that form like little pockets, and then when these pockets collapse, you get this scattered escape.
No, what are you talking about?
Well, we've just covered.
The shiny stuff is actually throwing me off. It's covered in something.
Okay, so the tubes up here on this, do you see the higher
So just a jumbled mess of broken sheet flow here.
Are they tubes, or are you getting tricked like I was getting tricked by the glass?
The shiny bits are basically basalt glass. And this is a lava pillar that we're looking at, where the lava came up inside and cooled in the water, and then the lava retracted again.
I'm not like leaning in front of you.
And here you can see the edges of the sheet flows where the lava came out. So all this area is a fairly recent eruption. It's between 10 and 20 years old. We know that because of previous visits here.
Imagine a basketball being deflated that was trying to be a pillow, and it just drained out and then flattened.
It's a little swimming holothurian, the purple guy. See, there's none on top here. It's as if they were all found in one spot, Tom. We don't see anymore, and they were just in that depression.
That often, according to Andy Gooday, that often is about how the current is flowing. And so often this happens, but he doesn't actually know why.
Raina, there's a couple more here.
Okay.
In the crevice.
All right. Say I'm wrong.
Not as abundant.
Yes,
If
right.
you noted that, you got it.
So we can make tracks. We don't actually.
It's more the ship position.
Ship position.
Yeah.
Okay, great.
Yeah,
Fine.
too fast,
Yes.
not
No.
being
That's fine.
I mean, I just found out.
Floats at 4 and 10. Look for floats at 3 and 4 and 10.
It's 4 and 10 to that one.
It just looks so small.
This is gonna be amazing posture.
Yeah. That's gonna be great.
So this is a
It's probably about it for sediment. Kind of
Oh, you're that.
on the bottom. Just so it's really interesting to see how the pillars have split, so you can see inside the lava tubes, which is Mark was looking at that the other day. Like a rat tail there, a curly. Anemone. Now look at the comatula crinoid down to the left, bottom central here.
See those cavities you observe on the track, so you have fish, it all goes back.
The first animals to move on to lavas after an eruption are the sea cucumbers, who lick up the sediments. It takes quite a long time for sessile animals to settle on this stuff.
Yeah.
No, it's already put it in.
Oh, yeah, yeah.
control that.
Yeah, it's a possibility you guys.
Can you picture it? Yeah.
A little bit faster. 27.
It's kind of cool because I'm like, well, at least I want to skate, but actually a lot of cars you stand with they say that there's going to see, I mean, skates that you've seen the same brand of gear. Every day of the week, it's just continuing.
You can mention. I don't know how much
What's that called?
Jumbled sheet floats.
Well, oh, I thought this swirly stuff.
Those are ropey or curving folds,
Okay.
but they've been displaced by the movement of the lava. They push them up in piles.
Yeah. Very nice. It's pretty amazing. Just seeing the formations. It's
I think we're off the multibeam.
yeah.
Looks like we're off the grid.
Is that where it's from? Was that what it was?
No, that was
Was on the cover. Oh, right. Organis did some work there. It was beautiful.
I've got the real freak now. We're up there. Where's the multibeam?
North of surface.
North.
Yeah. Perfect. They're good, yeah.
It's a squidworm, pelagic polychaete, and a little, you can see how it swims with its parapodia outside, and it's shiny because it's got needles or setae of silica. And the big long tentacles are trying to catch food. You see the little trailing pieces off the end. They're predators. And he's got his mouth is called a squidworm partly because of the coils of the tentacles.
We are heading somewhere. Trace we already started to the northeast.
Yes, yeah, we're heading there, but we're not doing the transects on the way. Like we're not doing the photogrammetry on the way there.
We're moving away from the map.
Yes, we're moving away from that.
Prepared to see the features.
Try so afterward, go back.
Come back up.
Go back up.
Yes.
Yeah. You seen the white swan lobster? Monica with her eagle eyes.
Spotted one? No, I didn't.
The white, we've seen white swan lobsters, and that first waypoint that I dropped was when those type of animals started in higher abundance. And I don't know what they. I don't know what they are.
So there are a lot of normal deep sea Canada.
Okay.
I don't know if they are all red though. So when you see a white one, you immediately start thinking
Yes.
bent. And I did notice some on the Nautilus
Yeah.
imagery.
Have you seen like maybe 3 or 4 already? 3.
Yeah. It's okay.
Your eagle eyes.
So the question is whether they're lost from. Well, there may still be venting here. I mean, I saw them on the Nautilus imagery, and I thought there must be something around. It's a great crab in the middle of nowhere.
Yeah. Well, Mark said earlier that the type of seafloor, it's hard because it won't focus the flow. It'll just let it diffuse out.
Right. Yeah. The purple animals or sea cucumbers. They're the world champions in eating detritus from the seafloor. Actually, acorn worms probably.
Is that a carnivorous sponge on the right?
Yeah, could well be. This little guy down here. That little stalk.
Yeah.
You know when you saw the white filamentous things underneath the ledge, I actually wondered if it was kind of a sponge, like very small ones. Yeah.
Yeah, that looks like a sponge.
Yes, and not only that, it might have some prey.
Yeah.
Platyrizids.
That's the kind that we have.
Yeah.
Yeah, so this unprepossessing little white stalk is a kind of sponge that captures, with its sticky spicules, captures plankton, like the little tiny things that were on the stalk. And it slowly envelops them with cells and digests them.
It's dinner time, so people want to go eat and then can come relieve the people who vacation. I was just chatting with
Mark, is the Burmite, is that the white edge, the white stained
you won't
edges?
See, you won't see it at this scale, but if you see a close-up of the fracture,
okay,
the fracture will be lined with the white.
Okay.
So this episode is D7 here.
Well, be careful with talking about everything.
The very white things, xenos, fractures. So I'm curious.
So it's not that oxidation on the edge. No, okay.
Yeah.
Right, you see the edge of the fracture.
Fresh. Oh, it's going to be
Yes. Yeah, that's what I was wondering. You mean this? Whoops. I won't touch the screen.
Yeah.
You mean right here? Yes, that's what I was thinking.
It's not very abundant.
Yeah.
It's very small volume, just very thin.
I was just pointing out there's a white spot lobster
Yes.
coming up to your screen.
Okay.
On the left.
Yeah, this guy up here. So to us, those are often associated with hydrothermal vents, as you know. But they can also survive off vents by scavenging other stuff. So that's an observation. Thanks. So that would be a species of Munidopsis.
Okay. Okay.
Catching up stones in it.
On my shift, it worked out. We didn't have to do this, but we were planning on doing like half an hour. We didn't have to do it. Yeah, leftover, yeah.
We realized that our shift, we're missing a person, and we missed like this and also we missed some
So you put all his favorite people in there. Great.
must be.
About 65.
Like a different fish or a different type of fish? It was a different fish.
It's just seawater.
Sure, they can have like something like a big cell eyes, but they shouldn't. Focus on it. What's that? Yeah, I can go down. There's a big sail behind us. No, just I'll stop it. Still messing with stuff. Great garbage.
Yeah, go ahead, RV.
Yeah, can you come to that stuff?
Can we just stop the loop?
It's a bit like Hawaii, doesn't it?
So that lava morphology is created by flow pushing a curtain to form a crust in front of it. And all gets piled up and jumbled like that.
So it's just congealing. It's cooling as it's being pushed.
It's a crust on top
Yeah.
of the lava that's still flowing, and it's just pushing it along.
Right. But it's a secondary flow
Correct.
because this has happened first.
Yeah.
Yeah.
So these drain backs are continuously being refilled.
Right.
And then drained, and then refilled, and then drained. That's an example of something that you would become
I was trying.
Look at the fish up on the left.
Yep.
One of the ones, like, what, rootlets? It's not the blobfish.
Oh, no, they are, oh Lord. Oh, they're so pretty.
Do you know the name for it?
It's right back here. Can you read it? Oh, shoot. No, it's not. It's a special fish where the pelvic fins have adapted to be able to literally walk along the bottom. They're kind of goosefish.
I'll do that, you.
Great. Why?
Yeah. That's the most common rock on the planet, but we don't usually see it because it's on the ocean floor. Right. Geological fact of the day. Another collapse pit. Rabbit hole.
Pretty tired.
Hello.
Yeah, you can continue that.
Continue the move. What speed would you like? Is it white tide?
Sure. Yeah, my time is there.
Okay, do that now. Thank you.
So that little red fish is called a sea toad. I just found him here. But it is a kind of goosefish. It's an angler fish, so it sits on the bottom and attracts things in.
Verena, why are some, I've seen them before, but different colors. What is it about the colors of these things? Why do they have such different colors? I've never seen a bright red one. I've seen lots of gray and brown ones.
Yeah. In some cases, it's simply the absence of color because you can't see it, so they're not pigmenting. But red often is the sign of things eating carotenoids, but not in this case. I don't know. Yeah, red is black.
So what's the point?
Why not?
I'm gonna say something stupid, but isn't then like down here it's the first thing that's invisible? So even bioluminescence, so if you're gonna be a fish that sits in the seafloor and brings animals in, you want to be invisible.
How did we get over that?
Another really big xenophyte for
On the right.
Right.
Middle.
Okay, this is different, Sarah. These are lows. These are not sheet flows anymore. So these are low bake flows, which usually means you're on a slope. And there's an abundance of these, what we call pillow buds. These are small, sort of baseball size, which are basically sweat.
Lava sweat.
Sweating out of the tube.
they're also called legal literature protuberances.
Protuberances.
What's a mouthful? So they follow the slope. They're always on the slope.
Yeah.
So it's just like falls
That's
down.
right. So if you took a sheet flow, a lava flow, tilted it along, say it's just going to break up into rivers or streams, and they become tubes. And then ultimately, at the end of the tube, you get those.
Very first.
Oh, that's kind of like our little pyramidal red jelly we saw early.
What?
Couple of rat tails. Recurrent fish are really, really common in the deep sea. There's a whole bunch of species of them. Oh, so we've got some colonization here. Not much. Funny, I don't remember.
Hey, what do we have? Yeah, can we get a zoom on that middle?
There's another one there.
The two little
She's-
soft thing with that?
Yeah.
I don't know, because it looks like it's got the same colors.
Left or right?
You can start with right because you're closer to it in the center.
Alright. And
What are you looking at?
The little guy right in the middle here.
Yeah.
There's staining on the sediment behind.
Cool. Yeah, both of them.
Yeah.
These look like little bamboos because you can see the nodes in there, maybe.
It's all. Yeah.
So to me, that puts the lava a little bit somewhat older
Yes.
than younger, and it's got a bit of a hydroid beside it as well as the coral. So there's polychaete tubes down at the bottom, and then more xenophyphores in the back.
You could go lasers off for the zoom in there. Wow.
Yeah.
It's massive.
Is this the kind of thing that you want to see?
Yeah, I probably won't end with this guy.
Although,
Well,
here we go. This one.
And that's the same thing, isn't it?
Yeah. Yours. Left.
Really need them relative to event, don't you?
Relative to event, and we're almost at the waypoint, right?
We'll set it a bit to go. To 150 meters or so.
I don't know which waypoint that is.
It's the far right one of the 14.
39.
That's what we're going at.
Now, number 14 is where we're going to, yes. Yes, thank you.
Do you want to keep looking at it, or are you happy?
Yes.
Sorry.
So this is what he's done.
Yeah, so remember this is just where the skates are, so
Yeah,
11 was the yeah.
But it wasn't far. I was
No,
more or
it's not
less
far.
thinking that we should just go a little bit beyond it and then come in.
Okay.
down.
Yeah.
And it's not
As long
very
as
far.
we're overlapping and coming back, I didn't
Yes.
want us to scoot past these
No,
to
no,
get there.
no. The idea is we went as far as possible, come in here,
Yeah.
and then come back.
Okay. And is this kind of where the bathymetric feature is that it's everybody identified?
It's here, and I don't know exactly how this. I think this is in the middle here.
Yeah.
And so it's up here.
It's up there.
Yeah.
Okay, so it'll be like a that way, and then kind of come in on it, and then up.
Yeah.
Okay.
We have a
Very
nice
cool.
sponge coming up in the center here.
Oh yeah. So that's a glass sponge, the little guy down here. And the big shrimp at the bottom. So these are quite common in the on these Pacific rise. And it's got two little amphipods on the underside. And there is a benthic medusa just up above it, up here. I think.
That looks like
No,
work.
it could be an urchin. Yes, it is. And those are really long spines on it. I thought they were tentacles. But look at the little amphipods under. Your foundation species.
What does that mean, Anina?
Oh, bit of a joke that sponges and corals provide habitat for other species, so one reason they're deemed important in protection. But he's only got 2 riders on him. So.
And what were you calling amphipods?
Those little pink things that are underneath
Ah, gotcha.
are, yeah.
Hey, what's this? Is that mushroom coral over on the left?
But there's a Xena 5.4 down to the right on the bottom. And these may be as well. But then, you're talking about this
Yeah.
dude. Sorry, yeah.
There's xenophores all over the place here.
Yes, there are. So we sort of moved into pillow lavas here.
These are fairly
So-
large pillows.
And this kind of looks older here, especially with the colonization.
You want to have a look at that?
Just close up, please. Thank you. Appreciate it. So these look different, John.
Yes, I think they're quite different.
Well, that's rather pretty. Like Garcinia or something like that. That's what it reminds me of from the Northeast.
Yeah.
Pacific, right?
You're seeing different than something you saw in 2015? Was it? Oh, okay.
Yep, that's great.
Strong, this would be a sponge element, right?
Say that again.
Oh, sorry. You're looking
Oh, right
underneath?
below the mushroom? Yeah, that's
Yeah.
that's a little sponge.
Oh, sponge, yeah.
That's good to keep up.
Yep.
Going to 14 is what I'm
Yes. That's right. And then we'll turn back west. And come back on the. So we're trying to get to a place that's a cleft. And they did see venting in there, but really low in 2015.
Are we wanting to go nice and slow, like doing a transect, or just get there?
With a crinoid on the end of it.
No, yeah.
Yeah.
You want to have a look at the bamboo?
Sure, why not?
So yeah, that's the purple comatulid crinoid. And comatulid means that the crinoid has lost its stalk, so these have this has been a huge radiation of crinoids in the Holocene and Pleistocene. So, you know, crinoids, just covered in the Paleozoic. Then they went through extinction after extinction after extinction. There were just a few left in the bottom of the Cenozoic. And then they found a new lifestyle. So they lost the stalk, and the stalk basically develops into being these little cirri on the bottom, so they can walk and they can swim. Do you think those...
Are you wanting to see the nodes?
Yeah, if possible. But I don't know if there is any on this one. Oh, actually,
there's one right up there at the top.
Yeah, okay, perfect. Okay.
Okay.
Oh, no, but I don't want to leave the sheet.
You want to go grab some dinner here?
The fast one.
You know spaghetti ones?
Yeah, that was spaghetti one.
Kind of my
Can you look at that sitting there?
Yeah, don't. That's
All right.
That's all fine.
spaghetti one.
Before you run off, Rena, we're going to have a very quick standing only main lab science meeting at 6:30. Just a quick update. Some people have to stay in here. 6:30.
Yeah. But if you did that for like their association with the race pains, yes.
Kristen, take you out, Sarah.
There's so many people offered. Okay, don't hit the big button or delete anything from my avatar. Thank you.
And since that coral we were looking at, we don't dig in, not big enough. I asked him how big was. He said slightly over 600.
I'm taking $20 to sit over and shoebox. Headless chicken. Tom said that if you cook black cucumber, do you pull it to your fish?
That looks a bit too straight to be a coral. I think that's a sponge.
Yeah, it's another carnivore sponge. I thought you you say chicken earlier? We call them the headless chickens.
Yeah, I was just confused. I was taking a guess now.
Oh, okay.
Yeah. Usually call the dream or theory. This one.
It's so catchy. This might be. Actually, I don't know how far away we are. Things like this. No, I know, I'm old enough to skate. The chemosynthetic plants. At the bottom of it.
Okay. Do you want to be in charge?
Yeah. Darwin's arch order.
No, not too loud, just right. Oh, just raise up. I'm getting some.
I'm just like leaning into.
You look down in that crack there. Yeah. Yeah, I just want to see if that's some bacteria or is it just shiny white.
John, that's what Mark's been calling boromites, which is like exposed crack, something with aluminum.
Yeah. Yeah, okay. I'm satisfied. I'm satisfied. Story checks out. Yep, there's a crack. BOEH-LITE, is that what works?
BOEH. Yeah. Yeah.
Jasper, you and Craig can coordinate and see if your calibration line can fit on the flattest part of that mapping area. Not at the moment.
What is it that we're looking for, 14?
This thing.
was there 12 years ago.
There's a fish out there. Is that one way from 14 to fish?
High abundance of background animals. Does this seem to be some worms? Serpulid worms?
Yeah, so in the clefts, the walls were covered in serpulids, and then at the bottom of the cleft were the only living chemosynthetic clams. So, what's the waypoint number that says, like, clams on it? It's among the serpulids. Should be like 11 or something, or like 10, maybe 9.
Yeah, clam debris and boehmite in something that's cut off.
Okay.
Is that the one?
Can you take a look at it?
Yeah, yeah.
Probably would be in like living. Yeah, that's it. Number 9 is like the thick of it.
What are these green things that we keep passing by? There's like this really long green.
Yeah.
Well, I just passed one. I passed one of those green things. Those green worms.
You want us back up?
There's one right there. It's sucking in right now.
Oh, look at that.
Yes, yeah, wow.
Yeah, we passed a whole bunch of those.
Yeah.
That's interesting. Okay, thank you.
You want to get a good image of one of those?
I just never seen one before. That's really cool.
You entice it out again?
I can hand that back to you. So yeah, it's number 9. It's like the where we saw live.
You can't see the numbers on the.
Sabrina, I
The
had said
overtop number now?
go to
Almost at 14.
Once we get to 14, we'll just start heading.
I was just wondering what
west.
14 was supposed to be.
Yeah, 14. Well, no, that was the Pacific Whitescape.
It really was?
Yeah.
Oh.
Like it literally.
Oh, I thought you were joking.
No, I wish I was.
John, Sabrina was asking me to go like to the furthest points, and then we were gonna try back along
Yeah.
them. Yeah.
Yeah, so we're there now.
Yeah. And then I think once we get out of them, like I don't think we should do the transit before we like thoroughly, because then we have to look down, and our field of view is small, and it's like fly close. So
Oh, yeah,
while we're
no,
looking for this, like let's keep not doing it, and
Yeah.
then once we're like satisfied it's on here, then we test. Yeah. Does that make sense? As soon as we
Yeah.
look downwards and move forward, you're not actually able to like look and seek out fence anymore.
So you want to? We'll finish doing a spin around here,
Yeah.
and then as we're heading back west,
Like
you want to do the
so I
downward looking.
want to go to 9 and actually
Where is
surf.
9? I can't see it
I
on
think
there.
it's under the 10. So we haven't actually been there yet, and that's where that's the waypoint where we
Have the
Oh.
highest.
Okay, so once we've been there, then you
Yes.
want to
You're
do
like,
the
these
transit.
photographies
one.
But as soon as we start the transit, we look down, we see such a small field of view that like we could fly, meters within something and not see it. Does that make
Yeah. And how you want that 300 meters, or what's your
that would be a Monaco question.
300 meters?
Minimum. Yeah. Well, I mean, like, I guess this is a practice one, but I'm
It's a practice one, yeah.
Yeah. We can do whatever. Like, okay, I say 300 meters because if it turns out that we use it, then at least it's consistent length with the rest of my transfers. That's all I'm thinking. But if it's a practice one, it doesn't.
Okay. Well, why don't we just do a 300 meter practice one?
No, that's not right.
Okay.
And then at least we know how long it will take to, and then that'll help their planning.
Alright, I suppose.
Yep.
So what are we doing?
So I'm heading to 9, right?
Correct. Heading to 9.
Just directly below 9. Bring it to slightly.
I can see that feel of like wanting to get to 300 just in case you can actually use it. Oh, is it one of those peanut ones right there?
Yeah.
Do you see?
Right, ROV. Okay, waypoint.
wanted to know for you earlier because
we're not starting right now, are we?
No.
Okay.
we got white.
We got white.
Yeah. I don't know, but we got haze over here.
No, that was me.
Yeah, that looks like all
okay.
That just came from that.
Come on. Wow, you picked that up.
I was driving down the cave.
You scared the hell out of me.
I just said white haze. How did that scare you? Did not say 19. I said white haze. You misconstrued it. What's that? Oh.
You don't want to do a Death Star run?
Oh, I will. I just didn't go back in there because I had done that earlier.
No, we don't. No. I mean, I want to, but we shouldn't.
She was here. She's just gone for dinner. I think she'll come back though. Oh, yeah.
Well, seeing the sides is pretty neat of those walls.
It ties in. The only reason I won't go super in there is because of your expense. Oh, that's a good idea. I would have done it earlier.
So what other expeditions do you want to run? Okay.
This is the end of my string of expeditions. But I've been
Okay.
very fortunate enough to be involved in.
The three back to back are the Venus ones.
Just the swimming one.
What is that?
Had a 10-meter grid on the outline.
Right.
Yeah, just the Seafloor and March and yours and this.
Oh, that's sweet. You were very active, but weren't you like in another three too?
Yeah, I was
Yeah.
Did I say yours or ours? Who did I say?
No. Yeah, you did. That's sweet because we have like a lot of people who like feel like they were like literally on the boat and we feel like I told Cheryl. Yeah, she's like I wasn't actually there. I just watched it.
Kept the sheet warm.
So you did?
You want these guys?
I haven't been using.
Yeah, okay.
Okay.
Yeah, that's why it was available.
So we are just heading towards 9 and 10.
How perfectly singing.
2 hours west.
It's like a lion roll.
So far,
Nothing.
yeah. The idea would be to do the photomosaic transect for about 300 meters heading west from that point.
So there should be a cleft in here somewhere.
That's a deep pool of level.
A cleft.
Could just be this one right here on the other side.
Yeah, we probably.
I thought I saw you in one.
Yeah, well, I definitely
Yeah.
went in.
Yep.
Glass. Might be looking at a couple of days on.
And were they in the bottom of the cleft?
Mhm.
Yeah, we just looked down one.
Iron standing with it. How it was escaping out of it. And the head was too up shape.
That's so awesome.
I know.
John, can I just add, remember the waypoint thing? I'm just saying if we do go to 9 and there's nothing there, that was Gerard saying it was 20 or 50 meters to the north on like every bit of, sorry.
Yes.
Oh, but like look over there, the succulents.
Yes.
Right.
Oh, yeah.
There they are. So these white, the white swirlies.
Someone was going to see it. There's like 1,000 of them.
Okay,
Yeah.
first.
You want to go have a look at that?
Mm-hmm. So
Right where they said they'd be.
yeah, I think everybody's croaked.
Yeah, look at all of them.
Good question. What's the question?
Are they alive?
So these are the tubes of polychaetes that live on the edges of hydrothermal vents. They're serpulid worms.
Did anyone else wonder what that was?
I got arms. Can I come over to this area where there's a lot more of them?
Yeah, sure. So what we're looking for is just the white plumes coming out of the
White plumes coming out
of the worms.
Okay. I'm
The
just gonna come over here
tubes.
to my left where it's a
Yep.
little
No, that's
easier.
great.
Okay.
Yeah,
Can I get a wall right behind me?
it does see. You know, there's
There might be climbs to the left.
a bit of fluid. See, like there's a shimmer in there. Is that where you were looking, Mark?
Mark, where did you?
Oh, I thought I saw shimmering water in here,
Where
Okay.
the fish is right now.
but there are clams in the distance there, or snails. A lot more of everything.
Yeah. So I'm not seeing any of the tentacles coming out of the worms.
I'll get you a
That's what it. Yeah.
little bit later.
This looks like more shell hash than the video that I just watched.
Interesting. The nav is so good, Therese.
Yeah.
Right when you were saying, oh, you all said, oh, no.
Yeah.
Yeah. There's nobody here. No.
Nobody's home?
What color are they when they're live?
They're white. The white plumes
Oh, okay.
coming out. Yep. That's great.
You don't need that stop.
Nope. No, what we need to look at is down to the left, which is where there were mussels. A bunch of years ago.
Farina, this is a lot more shell debris than when they flew through here in 2015. It was what they saw in the video was just one little pocket.
Yeah, we're coming in a different direction than they did,
So maybe just
and they may not have been able to see it from the other side. But because I don't remember the wall being quite so densely covered. Yeah, that'd be great. Oh, poor little guys. Bring back my fluid. Oh. You know that song, I Never Promised You a Rose Garden?
I beg your pardon? That one?
That one.
This is a noise you can grab off the TV. Yeah, exactly.
Are you using the computer now?
No.
Can you put it a little bit?
Sorry, Verena.
Eating.
Don't worry. It's not, you're not the camera.
So it may be okay if I just squeeze down here to get a better shot.
But
I've done it many
no.
times. You don't want to be there?
Who's this woman at my feet?
Oh, that's a cool one morning. Professional. So I'm gonna disappear. Yes, please.
You gonna have to zoom in on any more of these little white guys?
Not the white guys, actually. Let's see, what else can we do? Well, we might as well look. We're here. Oh, and they're beginning to dissolve too, so it's just.
It's coming up the wall from the bottom. That's why they're up there.
This used to be one of the huge flow right here?
Yeah, apparently all in the crack. I mean, there's enough shell hash at the bottom that. Yeah. there were still mussels alive. Did somebody say snails? Did somebody see snails?
White snails. Oh, right now?
Yeah, just now.
No,
So
we
I
just
thought
saw the white shells in the
Okay.
background. He's just doing a permanent squat. It's definitely a joke.
Yeah. Okay. So the fluid would be coming from down in the crack. That would be only. Recording the disappointment, are you? No.
Is that back from where we came to start?
Yes. Yes.
Is there anywhere else I want you to go in this area?
So just continue on in the, if you can. I realize it's a little tight.
No, it's okay. Once I open up the other
Here's the thing. I feel like they try holding it further, like along, so maybe we can get a little bit of continues a little bit back. So that
It's a cleft.
Yeah.
There's one more patch that might be alive.
Okay.
Where at?
We just passed this. We just go back there.
To the right or to the left?
Right in the middle of the screen. Underneath.
Right now or turn to the right?
Right now.
So this area right here.
So just down in no, was
Yeah, but the same, but
down in here.
yeah. Yeah, in the patch before that.
So it's science meeting time. Kidding. I mean, it is.
I can't go back. I can't go back anymore.
Yes, that's fine. Yeah. I don't know. I don't see.
Did that cover
So-
the area you were thinking of?
Yeah, I was thinking that.
Okay.
I think they're all
Yeah, they're all dead.
ex-parrots.
So the idea now is to head back towards
I believe, yeah, you need to fly through here and then come out and head west, yeah. Please.
Oh, wow. Must have been quite a lot of fluid coming out of here to support everybody.
No, it's over.
Evan just said that the dead cell area is
How long
marked
does
to
it take
dissolve.
these
Is there any
things
estimate
to dissolve?
Well, that's a good question. I would have thought they might have been gone by now.
Yeah, you do get the sense of really shimmering.
Maybe one more zoom in down on the bottom.
Yeah.
And
Yeah.
so we've got one squat lobster left here.
I feel like there was a good
I think my phone over here is black and would blend in perfectly with everything.
How long does it take them to put like corn?
Was it two worms or the?
There's a crab.
Oh yeah.
So how long would it take for you to dissolve?
So no, the garden, the rose garden is.
We're going to the garden?
Well, this was all part of rose garden.
Well, I thought that was way more than
Well, so the whole okay,
whole area.
in terms of the history, but we can go back over that way, which is all part of it. So we're gonna go follow the trail of points, please. Markers. Well, pass through the most promising location for venting, but it looks like it's all ceased. No. Which is disappointment, but in a way somewhat expected from the observations from about 7 years ago here. So we'll move to a couple of other spots where there fewer signs of venting. You never know. Maybe it'll come back one day.
No.
There's another one of those green worms.
Yeah.
This is a nice system.
Could you get the whole thing in?
I'm trying to.
Okay, that is an enteropust.
No, it's not.
No?
No. That's a it's a proboscis.
Look at it. Oh, this one.
This is a spoon worm.
Pardon me?
It's what do you call them? It's one with worms that you can see, and they have extended proboscis, like fork. Not anything else here.
Yeah.
Yeah.
Yeah. Okay. No, you're right.
Tom, bottom left, is that one?
You're right.
Maybe can we zoom out? Spoonworm? Was it?
Spoonworm, yeah. Okay. Yes, you're doing it. Somebody Google on spoonworm.
Look at all the sediment that fall in there, and then
Yes.
do you see?
Do you see that? The sediment
They transport
going down.
Oh.
Yeah. So what was it doing with its back end, I wonder? Echurans. Echurans, yes. Thank you. Thank you, John.
J-Rod, there looked to be a limpet on the left side of the screen, lower left. Maybe if you just...
When I was zoomed in or now?
About now, but maybe move a little bit more to the left. We just want to look for Tom.
The green bit is all
There it
spinal
is.
fluid. And then
Yes.
I'm just worried that
eating
could be a hot
proboscis. That's incredible. Oh, it's a
Oh my god, it's a monoplat.
brachiopod.
It's a monoplat. It's a monoplat.
Oh my.
It's a monoplat. We need to have that.
Strike two.
It's
Neopalina?
We have to have it.
Oh,
We have to
okay.
have it.
and you need to listen to him of what this is. It's an amazing find for lipidologists.
I know what it is.
So this is the rarest class of mollusks, and it's a living fossil.
So are we collecting this?
Yes, please.
Is this possible? So the glass might be quite friable here.
So is it going to be super stuck on?
No, smash around.
Okay, Tom, why don't you come on up then?
It's not sediment on glass chips. Those are like cheese.
I like that sound.
Oh no, that's
It is.
It's over there.
Or to try to lift it off.
Yeah, we can try to lift it off.
Maybe there's jazz back
Is it gonna be? Is it like really stuck
on,
on, or will
This
we be
was
able to
found
coax
in
it
the
off?
deep sea.
I think you can, but it has to be very, very
Allowed
The other
allowed
thing is you could like lift
paleontologists to understand what morphology was and modern cognologists to understand how physics evolved as a really strange morphology. Anyway, you can do a whole bunch more. You learn about it in your vertebrate zoology class. Then you learn about it in vertebrate paleontology class. So who said I know it? Go what? Somebody knows your secret.
Grab that camera control over there. Make sure that I can reach it. Where are you going to want it to go? And
So, on the boxes or
no, it's up to you.
which tool that you can use.
What did I say? I'm telling you here.
Okay, so I can use the bow box.
Our first collection. Our first collection. Yeah.
Does everybody remember what to do? Like, where's the sheet?
Oh, yeah.
It's not my ship, goes to your ship.
No, there should be three people filling out that sheet.
Okay.
So everyone who has the sheet should fill it out.
In practice.
We have 7 shelf buckets of seawater for this guy.
We get at least 2 out of 3 the sheet says. Yeah, well, yeah, 3 people each have copies of the sheet.
You're done.
Yes.
I learned about them back in like my first section.
Ah, great.
It's like an ancient service and it's much more than that.
Well, we don't know yet. Until they actually move on.
What's going on?
You want to keep around.
I want to see this one going.
It's funny to see you squirt. Yeah, sure.
Oh.
Something comes up.
He wants to come with us.
Terrible swimming.
Yeah, you don't.
That's far enough. That didn't scare me enough.
Good, now he's safe.
What are we calling this thing?
So the thing is you're going to be looking for on the whole rest of the services.
Yeah, this is not
expected.
No, but
That's
it's
right.
exciting.
Mike, I don't think this is.
How firmly is she adhered to that?
You can only run into these things, you can't aim for these things because they're so rare.
Sean?
How firmly would he be attached to the rock?
Yeah, like should you be like low section?
Break the glass.
Oh, break glass. Okay.
Couldn't suck him up.
So I can try to slightly scrape them off, or no?
Maybe try to break the glass.
Yeah.
Around it.
I mean, that.
Yeah, that's what I was thinking.
Yeah. Super clear.
There's nothing else on the sheet.
Oh, that's quite brutal.
Oh yeah.
Nice.
Not helping.
Oh. Not this large tube. It was definitely moved. It definitely moved.
Is there anyone for the scoop?
We got scoops.
Is the scoop on board?
Yeah, not on the vehicle now. Vehicle hit it.
Throw it down. Oh, it wasn't even stuck. Come on.
Yeah, I think it might be a one second. Let me just move this one off real quick.
Glass that's sectioned out.
Clear the.
I think we had like control over how much they suck so they can start like blood flow.
This is what I. Yeah, if I remember the two. Moving something.
Yeah.
Some we've gotten bigger. It's pretty hard.
Oh, I did. I keep exiting out of this. Yeah, I'm not staying on.
It's more like a Timbit. Yeah, I don't want to go now.
This is a glass of wine. And
Wow.
it's my grandfather, the raptor.
Oh, yeah, of
So they
course.
brought me in for a glass of wine. Could have been. Yes. But don't tell anyone, he said.
Oh, he loves you. or that when we'll stream it live to the world.
You really wonder how they reproduce. Where's the next field line? No, it's not there yet. We have to
Not yet.
Wait a second. Can you see the drawings?
Yeah, they're right there.
Oh, we can see.
Let me make sure.
See some flags.
I'll let you know. Yeah. It'll be there or in the lower left over there. He's got to make his way up the hose.
It's super long.
Be the fastest it's ever moved in this way.
More sediment.
Shortest meeting so far.
else you want to do in this spot right here, right? Maybe.
Okay, we already have a meeting. Non-essential personnel.
What's that?
Yeah. I was just in the hose somewhere.
Yeah, no, not all the way back there. Yes, you could. We could probably try to stop my hydroelectric.
I'm amazed you recognize it. Just the shell shape.
It's actually the structure, the microstructure of the shell is a sheen. And that's unique. It's unique.
It's unique.
Yeah.
Okay. Cool.
It's very fine reticulated structure.
So exciting to see it. You know, we all have to study it. Well,
It's something you don't aim to get.
No.
You can never expect to find it.
We're not entirely sure.
Enough to take over in addition.
Well, going in there. You're keeping an eye out.
Yep.
You keep that suction on while we're driving.
Just see if he pops in?
Yeah.
Alright, I'll keep an eye on him.
Sorry.
Alright, so it's somewhere in the hose, so we're just gonna leave suction on while we're driving. See if we get it in there.
I'm just heading over to the waypoint one, correct?
Yeah.
Not doing any transit or anything?
Oh, they're not in the room, so we will just keep driving until they come back.
If you're just joining us, about 6.5 hours into our dive here, or into the dive stream. And this is dive 603 of the remotely operated vehicle SuBastian. So we're currently 2,450 meters below the surface of the ocean on the Galapagos Spreading Center at a hydrothermal vent site known as Rose Garden.
Yes, I'm just letting you know that you own that.
We spent the early portion of the dive mapping, and now we are actually down on the deck exploring this site and looking for potential samples.
Not a lot of those collected in the world.
Yeah.
Sarah, we were talking about background water. Is that something you're interested in?
I didn't know that you were actually studying CTV.
Yes.
No, I'm just getting from CTV. I think there will be more difference in things.
I was just saying that we have the 4 Niskin bottles on.
Do we have lasers on?
Depends where you want to deal with it. Anyway, think about it. You got some time.
Yeah.
Where'd you go?
So it might be worth once we pass 5.7. It's a big one.
That's a skylight. There's that curved thing we saw in the videos.
I think those are.
As soon as you ask that, throw it out. Just so you know.
So this thing isn't even a liquid, it's an all class. It's a kingdom, phylum, class.
Okay.
So it's called a monopropophyr.
It's in here a lot of liquid.
Yeah. It's okay. It looks like a liquid. You can read it that way.
There's a monodopsis.
Oh, is this small?
Is that another name for squat lobster? Squat
Yes.
lobster. Although Randy tells me it's not a lobster.
So we're going to inconvenience you again.
Oh, yeah, that's fine.
Not exciting enough to do anymore.
You take your creepy little white thing.
This?
Okay, so continuing our transact west, just see whether or not we can find any venting in this area, which used to have quite a lot. So we're going over some hello lavas.
Sir, you get a treat this person to do that.
So it's like 90 trends, and I'm just going to put a very clear here. It will start with. Really in right now. But also, if you notice things,
How long ago was that? other expedition out here that you all got these big ones?
2015, so 7 years. So Maria, that kind of sediment sounds useful, right?
Yeah, we will be able to collect.
Yeah. So that's sort of what I thought was the next.
Yeah, that's good. So that'll be. Is there any concern about Galapagos, or is it fine? I would say like ones or so. I'm just gonna look, sorry. I'm not interrupting, I'm just
Oh, it's there. Oh, you got it. It's there. It's in there. It just came in, yeah.
Did it?
Ah, you got flapping tape?
Oh, up top.
No, just below the number 1. See it flapping?
Dude, I didn't see it come in, but that's on me.
Well, then they can just control that.
Alright, it's in there.
Which one?
Number 1.
It's in jar 1.
Number 1. So who has the sheet?
We're all supposed to be ready.
Okay.
So I have it in SS1 for those sheets, just in case.
I do not.
Mollusks before they can get their shells, soil different. You know, just continue when you say forest. So good for you guys. That's great.
Jared, I think it was in there for quite a while. Yeah, I wonder if we just didn't see it originally. I'm going back through the footage now.
No more security.
I'm like looking for it.
Waters that don't even trying to make geology
Nice beef.
One of the ones from the Galapagos was like a bunch of observations. It's just like
Can I ask about the
Yeah.
next, the next waypoint that we're moving to?
Although there's no venting, I wonder if they'd use it.
Could be doing the practice transect while we're going there.
Yes, now
For
that
sure.
you're back here. Yes,
Okay,
I
good.
meant to ask you that.
No, that's okay.
Yeah, for sure they do. And the one we saw on Octopus Odyssey,
Still coming over the 1. Okay. You want to stop by one on the way?
No, what we're interested, let's see, 6, no, 6 is fine, no, of terrible interest. But what we'd like to do is a practice on what a transect would look like down the road. So,
Yes.
can tell you
Well, actually, because we're going to run it with Monica's protocol, and then I'm just going to use her data. So it'll be Monica, ASCII, and I guess the first question would be is how far away are we from the next waypoint that we're going to go to? Because Monica's hoping for a 300-meter transect.
300 meter, okay. So,
650 meters.
so that's the distance to waypoint 6. Okay.
Okay. Nothing particularly, like I
And
wouldn't
it's not
aim
even-
for 6.
and that's not even
I would like
interesting.
aim for 5.
We're going to aim for 5 is more interesting.
How far away is 5? And Farina, are we going back along these waypoints and then taking a turn and going up to that bathymetric feature to finish?
Yes.
Okay. So if you're happy doing some of the transit towards 5 in this mode, I'll grab it.
Well, they're not.
Showtime.
She'll just,
It's survey, and there's actually buttons for it under survey. Visual, yes, and so it'll be a translate and start and all that stuff. No. Well, that's very important. So you want to communicate. So how do you communicate? Right now, not one of your aspects. You're going to ask for the ASAP. 1 second, downward facing, lasers on, for all of it.
Okay.
And you might want to describe your movement of the camera to keep that constant visual, even if they go up and down. Remember, you might just spin around. I'll be back here though. Okay. You want
Have a seat. Yeah.
Wow. Okay.
So you're geology?
No, this is the practice transect. Okay. Did you want another collection?
Are you going to want me to kick over to ASNAP 1?
Yes.
Okay.
Yes. Yes.
I'll do that right now then. And then just let me know when you want it back.
So this transect is
So right before we start, we're going to want to get the altitude to 2 meters or less if possible.
Or less?
We need lasers on.
Check.
Light, I don't have a specific setting for it, but if it's visible and not overexposed.
So, like how it currently is?
Yeah, and then I also want the science camera perpendicular to the substrate, so I'm positioned downwards.
I'll get you as far down as I can without getting everything.
Yep, that's fine.
See how it's starting?
Yeah. Yeah, that's great. And then we're also going to want to start this thing to happen now.
Superset that happened up or Alright, it's over on 1 hertz. Alright, so and then you're gonna have to get the line work. So we're heading to what? What are we going to? So
just go to the
getting either a measure line or but a marker.
So this is
No, I
just said,
it's
north of the first line.
Oh,
yeah, you definitely can't call.
I know where you're going.
no.
Unless you
Is there not a plan to do this?
So is this
Yeah, we make anything work. The more downward facing, the better.
Yeah.
But yeah.
Was going up more, make it more
So,
Like, if you increase the altitude, will that change, or is it still
No.
Same. Okay.
If the terrain changes, then you're getting the northern lights going in this area.
Yep. No, this is great. This is great.
Yep.
The only thing, I heard waypoint 6, I just want to confirm it's waypoint 5 that we're heading towards. Yeah.
Okay, so we're going to continue towards that waypoint.
So it's actually
if
north of the original line.
if you get to a spot that you're heading downhill and it's not enough slope that the altitude exceeds as needs to be visible, we're just going to turn the ROV around and go down that feature.
And you want to go this path enough.
Sure. No, that's great.
Just a little bit after. Yep. Thank you.
So maybe something to like write down for yourself is like how much voltage are you getting with this terrain, and that might be a good justification for learning to know whether you're going to do the diagonal. Like because you can't look downwards, you're going to have so much shattered area that this might be a good decision making for actually flying it backwards. Because right now we have so much information from the terrain. Does that make sense? You know, you're like, oh, which one should I do?
Yeah,
Right. This camera angle suggests that flying it on the back would be the only way to get full coverage. Yeah, because we'll never see what's on the other side because we're looking at such an angle. So it's just something to consider and be like, oh, yeah, that is the reason to make that decision.
Yeah, absolutely. Okay.
When you said that, I have some visual additions and then you know, this is hard.
Yeah. Sorry, I should have asked that. I will do that.
So this would be New York line of California.
So this would be.
This looks really nice. I said this looks really nice.
This would be New Line now. But with this kind of here,
And don't feel the need to avoid vertical features. We'll just survey up and down them.
And then turn around and come down the other side of it. Always, no matter how
I
tall
just
it is,
very
or
briefly looked at
only
myself.
if it's really tall.
I think we'll do it piece by piece.
No, you can count.
This is actually our best opportunity to see Hydrothermal. This is the last. I think it was there the whole time.
I never saw it.
I never saw it go in. All the reason was that they collected microclimate from the CCZ and they're only zooming so much on the enough feed, but I never noticed it coming.
It's like that.
Sure is. In this
Right, and you don't have the right person in the room at the right time to recognize what that is.
I won't be able to do that without destroying all that is, because that's a great one.
Okay. So in this case, just
Or
over
just
it.
the right color for brackets straight on.
So what would be an option to say to destroy it, but what were you wondering?
Well,
If I should have turned around.
if I should have
No, it's not.
if we should have turned around, then maybe just.
But we may see cracks under here.
Yes, and
There are two valves on this stop.
if you keep and like this picks for you
Yeah,
smart,
so
right?
you're right,
So
you can
can
interchange
and no matter what angle you put it, just at, like, doesn't need to be just straight. So, I mean, this is why the test, maybe make note of the time right now and be like, did that, what is a big black spot?
Actually, we have far more brackets.
And then the next time you get that opportunity, maybe even if you go over it and you just turn around and look at it. We did that with the Facebook effect. Do you remember that? We like hovered over it and then we made the camera like pan and tilt and like paint it a little bit. And so you just need to get that visual once. Yeah. So next time try it, and then when you're processing it, you're like, oh, that was worth it. Or like, oh no, that totally was worth it. Right? That's what this is for. Yeah.
Okay.
But you remember us doing that, right? So
I do.
Fit in the crevices.
Yeah.
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 So like right now, because I'm not saying ask them to do this, but right now there's probably like 2 meters of the wall at a diagonal that we never saw. We had no idea what was there.
Right.
So then if you're like, okay, can we stop here and just turn or just spin and just like look at it and then carry on going.
Right.
You know, so you'd be asking for a stop, a spin in place, and then to look at it without hitting the board. Then turn back and continue forward.
Okay.
And
So
before
maybe
you would handle
yeah, yeah. So maybe this is the perfect
one
chance to try
test
it.
it.
Yeah.
So you want to kind of like think about that rock right there, maybe that pointy one, and be like, okay, when you turn, you want that to be on the right side of the screen.
Right.
I know it's hard to remember what it looks like. Because you want it to continue being a straight line as much as you can.
There's 3 species in the fjords that are really
This is what happens when you're running that.
Yeah.
I can wait and let it clear out. But you see everywhere I just comes up and over and hit those views.
Right.
That's what you're missing.
So maybe you wouldn't get the reconstruction, but you do still get like a presence absence of animals. Like you've got a visual now. I guess the trade-off would be when you now spin around again, are you going to have a dust storm behind you? But this is what this is for. We're figuring it out.
Yeah.
I also don't know, like on these ones, you can imagine asking for a tilt down, as long as it's enough focus on the porch, you can still cut those photos to get the porch out of it. Does that make sense?
Yeah.
You wouldn't want to run that. Yeah, you wouldn't run that. Want to run that for the little thing, but when you're going over a steep thing, if you don't want to spin like this again, you can be like, okay, let's tilt the camera down.
Right.
Do you get half the porch, but you know you have to go in and batch process those photos to get the porch out of it.
Yeah, absolutely.
Yeah. So maybe you could try that on the next over and see if that worked nicer.
Okay. Yeah. Do you see where this? I don't even see where that pointy rock was.
Yeah.
Already there.
Oh, okay.
I went there earlier.
Perfect.
So
I don't know. That's
this
good.
part
That's
is nice.
Yeah, this
So,
part
like,
is good.
And again, we did it on like the big basalt slopes. So maybe there's a threshold of like size where it's like worth doing this.
Yeah. Maybe where we like lift up and turn.
Yeah. This looks really cool.
Mm-hmm. Okay. Yep. Sure.
That's a good one. Yeah, because you otherwise you have to use whatever sensing you get.
Right. Yeah. Please.
They're running it back and forth. I don't think that's because you're not building it up. You're looking at the ground and you come back to the rest at all.
Would it be better to pause, lift up, and turn back down? Would it
just for 3 million.
Being down this low and this time of terrain. If we were flatter,
So
yeah, actually, yeah, they were a little bit faster than what I was. I'm going at 1.2 meter, I'm going half an hour.
ROV, all stuff there.
That's me heading in the same direction again.
Perfect. This is actually a hydroid, and it's yep.
So it's not taking any longer than it normally may.
Yeah, we sampled it on the cruise in March.
We're gonna get to the next green.
Yeah.
Which we
didn't know what it was then.
We didn't know what it was. Yes, at the northern line, yes.
That's cool.
And I'm really excited it's on the channel.
That's fine.
So it turned out to be a hydroid?
Yes.
Wow.
Yeah.
Very cool.
Is green water? Would you want to see if Kurt can come and put a little lens on that map? Unless you know
Oh, like I have on that map. No, I have them on my map.
well, he's got it on the computer. We had a survey lines before. Just see if he's on there.
I don't know how much you can toss rings. They're on if we're going this way, following this line, how accurate can we conduct this?
If we were to do like a popcorn and both waypoints in, and we just put it in autopilot, and all I have to do is just worry about going up and down and whatnot, it's very accurate. Coming back to be like spot on, free flying, pretty cool, but not like where you're exporting it. Super.
So maybe we should
You'll have over.
Maybe we should do it that way.
Just kind of listen. What's the next idea?
Well, I'm just, I'm wondering how accurately while free flying can he come back on himself? Like, how annoying. And he said,
like we did it, like when we did InSAS.
Yeah.
On that test out. That was really fun. Back and forth, but I was not like it would. I would have been like a meter or two off.
Right.
So
but you need that. Or do you?
Oh, for fixed 4D, yeah, you'd need the direct overlap.
You're right. So.
Yeah.
So we're
Yep. Does their snail trails? Did your snail trail stick around for a really long time, or?
Not really long. Well, I mean, I'm for a 300 meter transect at this speed. Yeah. Probably. Yeah. So like we still had it from when we were over at 8.14.
Okay. I mean, that might just be a bias in you're never going to keep it 100%. And
well, if I run an autopilot.
You're on an autopilot mode?
Yeah.
Can you control the up and down and stuff?
Yeah.
Can you pause it? Like if you needed to stop and go up and around.
You just have to preset the line?
Yeah, preset the line, yeah. There might be times where obstacles are like, whoa, and might have to like kick off the line, come back and check. Over 90% would be spot on.
Yeah. Is that something that takes a while to set up, or
no, it's exactly how we set up for doing every stuff.
Yeah.
You just give us the waypoints of where you want to do, or even if you want to eyeball it, that's you can just draw them on here. Yeah.
Well, I'm just wondering if in this test dive, if
you want to do a short area.
If you wanted to do a short area of it, and then actually try have it fly backwards. I don't know if that's a possibility to then have that data and be able to say, wow, that really was direct overlap, or like no, it's gonna because this is the time to figure out with this vehicle which one works best.
Yeah.
Yeah.
Especially flying at this speed right here, it's a little bit more than the road. You make my adjustments.
Maybe if they're okay with it, we could just use another like 25 meters.
Yeah, like you want to finish the 300 and then I'll let Serena know that, but I'm sure she would.
Just coming over and looking like
Yeah. This is making me very interested in the automated line of the grid instead of yeah.
So that's what they did for the
Yeah. Road posters didn't work and they manually flew it, but you know, it always just depends what vehicle you're working with.
Yeah.
Yeah. Okay. How many meters do you have left of this 300 meter?
What, so you want 200 or 300?
300. So 100?
Yeah, you got like 200 plus. So.
Okay.
I started at that in the back. That's where I turned around. So that's where I started. Oh, it is.
Okay. Because yeah.
So this is fine. I'm assuming we can finish by noon.
I mean, it looks to me like it's more than a third of what you've done.
I can go much faster.
Yeah. So,
you heard the game plan, J-Rob?
So I guess.
You heard the game plan?
Kind of.
Okay.
It was changing my. It didn't realize it was being said.
I just double checked.
Do you want to, like, just for trial sake, increase the speed by 3?
I'm just like favoring, so half a knot is going to be 125 meters a second, and I'm favoring more to 1.2. So I'm going to start getting the right 0.2 slash. I've just been slowly increasing.
Yeah.
there's gonna be where you may have to just sort of decide on like getting it to be 300 versus testing with different methods and then deciding which one you'd rather do.
Yeah.
I think the last
I would
word
rather
is
do the
just
different method.
yeah.
Okay, so maybe tomorrow, would you be able to kind of just like a 50-meter line with your waypoints just so that we can try doing that? Or if you just do it.
Yeah, quite a lot. I would say maybe 25 because you're going to fly 50 because you're going to want to come back on it.
Yeah.
So it was.
Continuing in that direction.
Yeah.
Yeah.
And then I don't know if it will I'll just go from your stage but like telling them that when they finish it you actually want to go back on it you might change how they ask the shape to move because they might think or if you're going in that direction or you're actually going more to
No, we control this.
okay.
You don't have to worry about this.
Okay.
No, we got
That's good.
Yeah.
So, yeah.
So,
We're doing this to test if we can come back on a cross, so we're gonna do like 25 with waypoint and then come back on the sun.
one that you know, start this
Did John confirm that 8 o'clock around this? Wasn't it right?
It's not super easy to get the lines up on the thing.
Yeah, that's fine. I didn't realize we would see this. So if you could. So what are those ones?
They're the waypoints on the grid.
Okay.
Yeah,
So
turn around.
to direct it to the pinnacle at the north.
Yeah, so for something like this, it makes sense.
Up towards 28 on the
isolate salt water relative to the expansion of the forest toward Russia. So, was there a time before where the water was active? Would be a long time. So it's at 33 then? Yeah, 33 about this one.
Thank you.
That's the only one.
Should change its over, at least you have to do like
This sounds like home too.
Oh, but wait, the watch leader is supposed to stay on for half an hour.
One of them was
You have to worry about these. I'm going to show them on.
both of them wanted to go further on Hagel, but the ice was too thick. So they came back and they went to Oklahoma. And they did some ROV situation.
But the photograph of like sites there's an active science and I can only do it once at the historic museum. But so the photograph you won't have. This is super informative.
So when
Once at the bottom, you can
so
go forward and not down. So
So what? Or 2 blocks of
I'm not logged into simulations.
Yes. Now, with this one, as long as you can see the seafloor, you'll ascertain whether it wants to come back on itself. You have to remember that if you run the interview transect, then as a determine trying to get straight where this communication should be on. So it's really like all you need is the visual cues that tell you that it's working. This itself obviously isn't going to make them.
yeah, for sure.
Yeah.
But, so I think
Test that
we're going back on ourselves. Yeah, exactly. Yeah, exactly. No, I agree for sure. We're just getting to this point. Yes. believe so. Is that what you said? I believe so. I believe so. Yeah.
Sediment? Well, we don't know. For the rest of this,
Oh, we did our well, that was the objective.
yeah. No, I've got a lot of files and stuff. Yeah. This was much, yeah. Yeah, when I get the button, I'm going to start how you oh, that's one of these. What's the total length of that? 600 meters.
What fracture is what line?
It's the east-west. There's an east-west.
I know, but fracture is what line?
Yeah, that's the problem. You can't. The lines are on there, but the wavelength, the numbers are 42.
This is going to be perfect because you going out in the future or you
We're close. We're close already. No. It's east.
No, that
can't be. It's
history.
history.
I don't think that else is
Yeah, sure. I can't read the numbers. 43. 43. So we're right at it.
Yes.
So we're, yeah, right here.
Right at it. Oh, it's all in the same direction that you want to go. So that should.
Is there any way
We'll go over
to
here.
keep those waypoints closer?
So if you
It's just to see what the M3 looks like.
We are at the end.
The waypoints are the 300.
Okay.
Do you want me to go faster?
No, if we can just, we don't need to complete the full 300 because we're just testing things out.
Yes, follow up.
So you're going to stop that transect and just move over there?
Yeah. Yeah. Yeah, let's do that. So stopping kind of down, and then just go over to our waypoint.
No.
Alex, you can take ASAP for 1 second just because we'll be starting this again.
Right.
Exactly.
I just want to see the plane view. Not totally made to read the numbers.
Okay, so while we're transiting over to this next waypoint, for this pass, we're going to experiment also a little bit with the lasers. So about halfway through the 25 meter, we can turn them back off. Keep them on for now, but then we'll, turn them off after.
And then on the way back, keep them off until halfway back and turn it back on. So both sections of the 25 with lasers?
Yeah.
top there, right? Yeah. So it's positive.
Not even full cover.
But it hasn't done anything yet. They said they wouldn't know until it did. And there's no in between. It's either 1 or 10 seconds. So it's like really looking for one. They said they'd have to write the script to make it something different.
Okay. That sounds good. When we get to the point, can we get can you just tell me? Let me know so we can press start on the program.
Someone's trying to figure out the signals.
Just make a blank. The one you collected.
This is one.
That's how wrong. And then so it's just like, these things in it's amazing because like if we didn't hurry, we would have been that
Slow down over here.
that's moved on.
Yep.
That knowledge is that all the fine decisions.
This isn't interesting that small of a thing.
Yeah. Yeah. Well, the world's crap is flying up. Is he good? I'm excited because I put in an acceleration and it was that so like that. It's very distinct. That's why I got marked.
You can just go right ahead.
Basically, right. Yeah. No, that's true. That's, yeah. It's fun having
While we wait for it, we spend on this.
it's like, sure, you peaked now, like, you press it one and you're like, I was not coming here, and you know, you can do it, and not showing anything else.
We don't need to do the full wrap around, maybe just
I got a lot of time to do those again. I'm not.
That's the way you model
That's
this.
great.
okay. If we're here, can we get a zoom on those little spots beyond the
Yeah.
are those
Sarah, yes. Could you make a note, an observation, like, just write an observation,
so this is the thing where it's going to be
photogrammetry of
potential
color.
so
I want to see if I can reconstruct that.
yeah,
Thank you. And it has to be something you can see. Like, it'll move overnight, but then it'll give it it'll give it black underneath, but it'll still protrude just as far. Like, it'll give it its accurate dimensions. Real friendly, like, what's actually like flying over everything. It's such a good graphic.
actually can we figure out the
Yeah, the carrier, one of those carrier covers.
is that a sponge?
Sponge, and then look inside the sponge, and then it's a fish in the sponge, and fish is 3D in the sponge. Yeah.
Or maybe run it. Tube. Or politics.
Absolutely not. And it's an endeavor like academia for you.
Like a cat spot. I love cat spot shells. Yeah, it's all like they get very specialized.
Yes, actually now that you mention it, InSAS I've already seen them.
Oh, there's some gorgeous ones. There's actually someone for
Oh, look at that.
He's scared of something. What is that? Ooh, it's one of those crabs that like
Carry.
So he's carrying his little sponge. You just
That's
said
so
it. Yeah.
cool.
And an enemy.
See nothing. I think this is an
Yeah, sometimes they've got
enemy.
sponge.
You don't think that's a sponge?
I'm straight through.
It's alright, he's waiting on.
Okay. I'm going to see that.
We had someone. Well, I was gonna say like the anemone makes sense because it stings. But we had someone last cruise who was talking about sponges may have some olfactory.
That's
I smell like a sponge, not like a crab.
Right?
But because we were beyond their visual camouflage.
Yes, it's the conception. That would make sense.
But I don't know.
What are the
Pretty good spot.
What's with the
do you see the red?
So that's not a sponge.
No, it's an urchin.
No.
That's an urchin.
Ah.
Wow.
Okay, that makes sense.
You can see the pedicellaria.
Yeah, reaching out.
Yeah. And so, who wants to live right in the crab?
It's got it's an urchin. Yeah. Goes in defense for sure.
Yeah.
I wouldn't do it. That's cool. I've never seen one with an urchin before.
I'm logging my always see
Doesn't want to collect.
Okay. Can we bring this back in again, please? Can we just go through the checklist again just for the sake of repetition and get it monitors? Okay, so A-snap, 1 second.
Yes, it's been on 1 second.
Perfect. Camera position, science camera position. Yeah, this is go through the checklist.
That's the second one. Can you change that? I'm gonna move it a little bit. Just gonna move it up. And then after I get going to this one. Are you ready?
Okay, so camera, checked. Light, check. Lasers, on. Speed set to 0.5 knot. Okay, transect starting now.
I've seen the ones that like have an actually working on Schmidt just assumed like everyone here is
What's that?
yeah.
Yeah, I know. Went up.
Where was that?
I had a manual change.
Lasers all halfway.
Lasers all halfway.
Yeah. There's great photos of that.
Perfect, thank you.
So earlier, like I actually can take out the cover on the website for a while.
That looks great.
Yeah, that's why I had to put the trying to slow the cup up before it turns.
So that 50 mark is an outdoor spot for this thing if I try around again.
And that's me running back down the line. No, turn back on that. That same back. So the second is the same as that.
Well, maybe.
Okay. I thought you wanted.
No, you're good. Okay, sorry now.
Yeah, I thought I assumed you wanted that same as that laser there. That's what my
Yeah, that looks perfect. So this one, I think that's what it is. And the start
the longer you wouldn't get all this settings.
Of course, yeah. But this other bit didn't look that bad at the beginning of the chance. Thanks, Carl. Okay. Stop perfect. Okay. Alright, thanks guys.
Good for a snap to go back to 10?
Yep, good for a snap to go back to 10.
Okay. Okay, you're done. You're on now. I've got my computer up there. Start changing over the watch. And we got the hardcore dude here.
What do you mean?
Oh, you wrong man. Okay, I have my computer. Be careful hitting the screen.
Not that I can.
Okay. I also like because these guys are gonna leave with their gear, so one of us should just for the transition,
So
and then we can sort it out.
we will be back again before the game. Since they should be in the water. Have you, this is a stream.
Alright.
Thank you. And then I'd say we can debrief, but if you just start logging in,
All right, we've got a little bit of a handover happening here, and it's about time for me to restart the stream, actually. So, if you're watching live on YouTube or Facebook, I will be ending the current stream, and just keep an eye open for a new stream in the next few minutes, and we'll see you in part 2.